Hello there, and welcome back to the Sleepy Explorer. I'm truly glad you found your way here tonight. Think of this moment as a quiet refuge at the edge of your day, whether you're nestled under heavy blankets or lying awake with only the soft glow of your screen keeping you company in the dark. However you've arrived, this little space is here to offer you calm and maybe a touch of wonder. Before we set off, I'd love to know, where are you listening from tonight? Maybe you're curled up in a quiet bedroom, the glow of your screen the only light left, or perhaps you're on a balcony with the night air brushing against your face, stars scattered above. Wherever you are, leave a note in the comments. It always feels like watching a constellation of sleepy travelers appear, each shining softly from their own corner of the world. And if these gentle explorations help you find rest, consider giving this video a like or subscribing. It helps this dreamy little channel float a little farther, and it may guide others here too, those who, like you, are looking for a soft voice to close the day with. Now, tonight's question is one that seems almost too big to hold. How vast is the universe really? Is it simply large, or so boundless that even the word infinite feels too small? It's the kind of question a curious child might whisper while staring at the stars, and the deeper you think about it, the more it pulls at your imagination. It asks you to picture distances no ship can cross, horizons no telescope can pierce, and mysteries that stretch beyond comprehension. But don't worry, this isn't a lesson you need to memorize. If your eyes grow heavy, let the science itself be a lullaby. And if you stay awake, you may find yourself with a new sense of awe for just how strange and beautiful the cosmos can be. So, take a deep breath. Let your shoulders relax. Imagine your thoughts floating upward like balloons into the night, higher and higher, until they brush the edge of the stars. That's where our journey begins, on the threshold of immensity. And let's drift into tonight's story together. You start right where you are now. Look around your room, the walls, the furniture, the phone in your hand. Everything feels stable, solid, and comfortably human in scale. A bed is big enough to stretch out on. A room is large enough to walk across in a few steps. A building takes a minute to climb. A city can be crossed in an hour if the traffic is kind. These are the scales we live on, the scales that make sense to our brains. And yet, if we pull back just slightly, say, to look at the Earth from above, we realize how minuscule even our greatest constructions really are. Imagine yourself rising, slowly, as though carried upward on an invisible elevator. The city below you shrinks, its skyscrapers turning into toy blocks, its cars into tiny dots of color crawling along veins of light. At a few kilometers up, you see the city dissolve into the larger landscape rivers, threading like silver ribbons, mountains folding against the horizon, coastlines curving with patient grace. Keep rising, and soon the whole Earth comes into view, a glowing blue marble wrapped in the soft whites of clouds. From this vantage, everything you've ever known is contained in a fragile shell of atmosphere, no thicker than a painter's glaze on a canvas. And the first revelation strikes. Earth is already small. In fact, in cosmic terms, it's practically microscopic. The sun, that familiar golden disk in your daytime sky, could swallow more than 1 million Earths inside its fiery body. It sits at the heart of the solar system like a bonfire, and we orbit it at just the right distance for liquid water, warm beaches, and late-night strolls. But that comfortable orbit is a speck, a narrow thread of habitability carved out of an incomprehensibly vast solar structure. Picture the solar system now. The Earth's orbit is just one ring among many. Mercury darts around quickly, close to the sun, while Venus glows pale in its thick cloak of clouds. Beyond us, Mars waits rusty and cold, yet a tantalizing frontier. Further still, Jupiter reigns with storms that could engulf our entire world. Saturn shows off its elegant rings, and Uranus and Neptune mark the edge with icy solitude. The whole solar system stretches out to billions of kilometers, so wide that even light, the fastest traveler in the universe, takes more than 5 hours to reach Neptune from the Sunday. Already, the scale has grown so far beyond human comprehension that numbers start to feel slippery. We can say that one astronomical unit, the Earth's distance from the Sun, is about 150 million kilometers, and that Neptune is 30 astronomical units away, but those are just digits. To feel it, you need to imagine driving to Neptune in a family car. At highway speed, with no bathroom breaks, it would take you about 5,000 years. Suddenly, Even the longest road trips don't seem so bad. And yet, here's the thing. Our entire solar system, the sun and all its orbiting worlds, comets, and drifting dust is just one star system among hundreds of billions in a single galaxy. Our galaxy, the Milky Way, is a spiral of stars so wide that light takes 100,000 years to cross from one side to the other. That's not 100,000 days, or even 100,000 human lifetimes. That's 100,000 years of light, travelling at 300,000 kilometers per second, non-stop. Wrap your head around that for a moment. You may find yourself imagining little glowing photons, particles of light, leaving one end of the Milky Way and only arriving at the other end after the entire span of recorded human history. From the first cave paintings to your phone screen right now, that entire sweep of human culture could unfold while one single beam of light trudged across the galactic disk. It's humbling, and maybe even a little dizzying. Scientists still argue whether this scale is even the right way to think about the universe. Some prefer to measure not in kilometers or light years, but in powers of 10, expanding our mental map step by step. A meter, 10 meters, 1,000, a million, a billion. Each jump multiplies the scale until you realize how quickly human measures break down. By the time you're at 1 billion meters, you're not talking about roads anymore, you're talking about planetary orbits. But even the Milky Way isn't the end of the story. Lift your perspective higher. Imagine floating above the spiral arms, watching their slow swirl of stars. Then keep rising until the galaxy becomes a single glowing disk, like a coin of light tossed into the dark. Around it, other galaxies come into view. Andromeda, our nearest big neighbour, sitting just a couple of million light-years away. The large and small Magellanic Clouds, irregular galaxies that orbit our own, trail like companions. Soon, you see not just one galaxy, but dozens, then hundreds, then thousands, scattered across the black like grains of salt. Galaxies are not isolated wanderers. They cluster. Gravity binds them into families, groups, clusters, and superclusters. The Milky Way belongs to the local group, a small cluster with about 50 galaxies. Beyond that lies the Virgo cluster, with over 1,000. And all of these clusters are strung together into an even larger web, the cosmic web, a lattice of matter stretching across billions of light-years. Imagine filaments of galaxies like threads of glowing silk, knotted at intersections where superclusters form, leaving behind vast dark voids in between. Here, the imagery grows surreal. You're no longer thinking of galaxies as individual pinpoints. Instead, you're watching the architecture of the universe itself, a structure so immense that its patterns echo the firing of neurons in a brain. Scientists have noted the eerie similarity between maps of the cosmic web and maps of the human brain's neural networks. Is it coincidence? Or is it telling us something deeper, that consciousness and cosmos mirror each other, fractals of complexity repeating at every scale? This is where awe shades into philosophy. You realize that in some sense, the universe is not just out there, but also in here, within your own awareness. You are a tiny speck, yes, but also a self-aware speck, capable of gazing at the infinite and asking what it all means. In this way, the universe contemplates itself through you. And yet, the mystery deepens, because when we try to measure the universe, we quickly discover that most of it is invisible. Only about 5% of the cosmos is made of the kind of matter you and I are familiar with: stars, planets, atoms, coffee mugs. The rest, a staggering 95%, is something else: dark matter and dark energy. Dark matter holds galaxies together like an invisible glue, while dark energy pushes the universe apart, accelerating its expansion. Without them, the stars wouldn't shine in galaxies, and the galaxies themselves would not drift ever farther from each other. Scientists still argue whether dark energy is a property of space itself, a new field, or something we haven't even imagined. Some even wonder if our entire model of gravity is wrong at cosmic scales. For now, it remains one of the deepest enigmas in physics, a reminder that no matter how big we think the universe is, our knowledge is far smaller. The more you drift outward in imagination, the more fragile and small the human scale becomes. Think about your body right now, lying on your bed or leaning against a chair. Your heart is beating steadily. The atoms in your body were forged in ancient stars billions of years ago, and yet, as ancient as they are, they belong to a species that has only existed for the tiniest blink of cosmic time. Homo sapiens, about 300,000 years old, are barely noticeable against the 8 billion year sweep of the universe. If the universe were a single calendar year, your entire species would have emerged in the last hour of the 31st of December, right before the fireworks. Now, consider distances again. Light from the sun reaches you in 8 minutes. That same light takes 4 years to reach Proxima Centauri, our nearest stellar neighbour. 4 years may not sound so bad, until you imagine being on a spacecraft, watching birthdays pass, holidays come and go, and still having nothing but the darkness ahead. And that's just the closest star. To cross the galaxy, you'd need 100,000 years. To visit the next big cluster, millions. And beyond that, billions. Suddenly, the word infinite starts to slip onto your tongue, not because the universe is provably endless, but because its vastness outpaces every metaphor you've ever known. It helps, sometimes, to use thought experiments. Imagine shrinking the entire universe down into a sphere you could hold in your hand. If the observable universe, the part we can actually see with telescopes, were the size of a beach ball, then the Earth would be smaller than the tiniest atom. That's the scale we live on, an atom in a beach ball. And yet, to us, our atom feels infinite, filled with oceans, skies, mountains and cities. It's all about perspective. Here's another quirky tidbit. Your head is technically older than your feet. Gravity makes time flow slightly slower at sea level than on mountaintops. That means, if you live your whole life standing upright, the atoms in your skull will age a fraction of a second more than the atoms in your toes. The difference is tiny, but it's real. Einstein's relativity ensures that no two places in the universe share exactly the same now. This quirk reminds us that time and space are stitched together, and that the scale of the cosmos isn't just physical distance, it's the way reality itself bends and stretches with gravity. Scientists still argue whether infinity is even a useful concept here. Is the universe truly endless, or is it just very, very big? Some evidence suggests it might be flat and infinite, extending forever with no edge. Others suggest it might curve back on itself, like the surface of a sphere, so that if you travelled far enough, you could end up back where you started. Still others wonder if our universe is just one bubble among countless others in a multiverse, each with its own laws of physics. At that scale, even infinity feels cramped, because everything possible could exist somewhere, somewhen. But here's the thought that might make you laugh quietly to yourself. Even if there are infinite universes, you still have to get up tomorrow and brush your teeth. That's the magic of being human. The grandest scales coexist with the smallest routines. The universe hums at incomprehensible size, and yet here you are, living in one room, listening to one voice, sipping one drink, perhaps fighting sleep. The cosmic and the ordinary weave together seamlessly. Let's zoom back out again. Beyond galaxies, beyond clusters, the observable universe stretches about 93 billion light-years across. Yes, billion. How is that possible, you might wonder, if the universe is only 13.8 billion years old? The answer lies in expansion. Space itself has been stretching since the Big Bang, carrying galaxies with it like raisins in rising bread dough. So while the light has travelled for 13.8 billion years, the galaxies that emitted that light have since moved farther away. The balloon has inflated beneath the beam. This expansion means there are regions we will never see, no matter how powerful our telescopes become. They're beyond our cosmic horizon, receding faster than light because of the fabric of space itself expanding. It's like standing on a shore and watching ships disappear, not because they've gone over the edge, but because the ocean itself is widening beneath them. And so, when we ask, how big is the universe? The humbling answer is, as far as we know, bigger than we can ever measure. The observable part is vast beyond comprehension, but the unobservable may be infinitely larger still. Some philosophers take this to its most extreme conclusion. If the universe is infinite, then every arrangement of matter must eventually repeat. Somewhere, unimaginably far away, there may be another Earth, another you, listening to these same words, another version where you paused the video 5 seconds earlier, another where you chose a different bedtime snack. Infinity contains all possibilities, endlessly. It's a concept that breaks the brain a little. But it's also strangely comforting. In a universe that large, no single mistake matters. Everything will happen again and again, in some corner of infinity. And yet, here's the part that lingers as you drift towards sleep. For all its immensity, the universe is knowable, at least in part, by tiny beings like us. We've measured the cosmic microwave background, the afterglow of the Big Bang which whispers to us of the universe's earliest moments. We've mapped the large-scale distribution of galaxies, tracing out the cosmic web like cartographers of the invisible. We've estimated the proportions of dark matter and dark energy, even if their essence escapes us. For creatures so small, we've done astonishingly well at peeking into the grand. Perhaps that's because consciousness itself is not separate from the cosmos but a product of it. The atoms in your body were once forged in supernovae, scattered across space, gathered into planets, and eventually woven into neurons. Those neurons now fire in patterns that allow you to imagine galaxies, to wonder about infinity, to marvel at the impossible size of everything. You are the universe, briefly, looking back at itself. So, how big is the universe? Big enough that light itself struggles to cross it, big enough that entire galaxies vanish from view as space expands. Big enough to hold every possible version of you, every possible story, but also small enough to fit inside your awareness tonight, as you lie here and let curiosity become calm. And as we close this first chapter of the journey, let yourself hold on to this simple truth. You are not separate from the cosmos. You are a thread in its fabric, as essential as any star or galaxy. When you look up, you're not gazing at something out there, you're gazing at the larger body of which you are a part. Let that thought ease you toward rest. The universe is vast beyond measure, but it's also home, and no matter how far it stretches through you as well. You've seen how time bends, how it stretches and shrinks under the pull of motion and gravity, how acceleration tips the balance between travelers. But the real magic comes when humanity learns not just to observe this bending, but to use it. Time, once the master ticking relentlessly forward, becomes a tool in our hands, something we can measure, exploit, and even engineer into our machines. It's as though the universe gave us an impossible riddle, make sense of me, and instead of throwing up our arms, we found ways to solve little pieces of it, 1 second at a time. Take GPS, for example. You probably check it without thinking, glancing at your phone to see how far the coffee shop is or which turn to take. But behind that glowing blue dot is a quiet symphony of time dilation corrections. Satellites orbit Earth high above, moving fast enough that their onboard clocks run slower relative to ours, while simultaneously being further from Earth's gravity, which makes their clocks run faster. Two opposite distortions, pulling in different directions. If we didn't account for both, your map would drift by kilometers every day. Imagine trying to navigate a city where your GPS insists you're driving through a river or a skyscraper. Without Einstein, Uber rides would end in disaster, and pizza delivery would never find your door. It's almost comical. An idea once scrawled in chalk on Einstein's blackboard now keeps your Friday night sushi order from getting lost. Time dilation isn't just a curiosity, it's the invisible spine of modern life. And it doesn't stop there. Particle colliders, those giant rings buried underground, like CERN's Large Hadron Collider, harness time dilation in even stranger ways. Inside, protons whirl near light speed, their lifespans stretched like taffy. Particles that should wink out of existence in a whisper survive long enough for detectors to catch their traces. In a way, we've become time farmers, coaxing extra moments out of fragile particles, milking more existence from the fleeting. Scientists still argue whether this exploitation of time reveals something deeper. Is time dilation just a mathematical trick we adjust for, or are we glimpsing a truth about reality's flexibility? When you add seconds to a muon's lifespan or keep a GPS satellite's clock in sync, are you bending time or just reconciling our measurement? The debates swirl, but the practical effects remain undeniable. Time may be slippery, but it is also strangely cooperative. Now tilt your gaze higher. Astronomers use time itself as a telescope. When light from distant galaxies reaches us, stretched and redshifted, it carries not just colour but chronology. Every photon is a timestamp, a little diary entry from billions of years ago. By reading that light, scientists reconstruct the story of cosmic expansion, charting how the universe swelled and aged. Time here isn't just measured, it's mined, quarried like some precious metal from the stars. It's funny to think, your life is full of tools, forks, wrenches, phones, but time? That's the strangest tool of all. You don't hold it in your hand, you hold it in equations, corrections, and calibrations. It sits in your pocket each time you unlock your phone, whispers through each collision of particles underground, and stretches across telescopes to paint the history of galaxies. It is both intangible and indispensable. Here's a quirky tidbit. Some scientists dream of clocks so precise they could detect dark matter passing through Earth. Imagine a timepiece so sensitive that it notices a tiny hiccup in the tick-tock as invisible particles brush against reality. We might discover the universe's hidden scaffolding not by smashing atoms, but by listening for time's faintest tremor. That's the future of time as a tool, not just guiding cars, but unlocking secrets older than stars. And still, the paradox remains. You, sitting here, feel time as nothing more than 1 second following another. You yawn, glance at the clock, wonder how many minutes remain in this day. Yet above you, satellites argue with gravity, particles stretch their lives underground, and light carries messages older than the Earth itself. Time is everywhere, doing acrobatics, and you are serenely unaware. Maybe that's the greatest tool of all, the ability to trust time enough to forget it, while scientists labor invisibly to keep its slippery nature from tangling our lives. So tonight, as you imagine drifting through space, think of time not as a prison but as a toolkit. Think of the engineers who tame it, the physicists who wrestle it, and the cosmic historians who mine it. They all remind you of a simple truth. Time is not just something you endure, it's something you can use. You can think of it this way. Time dilation is no longer an odd quirk of the cosmos, it's an industry standard. Airlines, communication systems, even the financial world all lean on relativity to make sure their clocks agree. Banks, for example, rely on transactions stamped down to the billionth of a second. If one server drifted even slightly, money could vanish into thin air or duplicate itself like some glitch in a video game. To prevent that, the guardians of finance look not just at calendars and wristwatches, but at atomic clocks. The devices so precise they could tell you if a mountain goat just leapt onto the roof of the laboratory and changed the gravitational pull by a hair. Time as a tool is everywhere invisible. You depend on it when stock trades race across oceans, when phone towers triangulate your signal, when streaming services decide whether your favorite movie starts on time. Each of these depends on synchronization, and synchronization depends on relativity. It's wild to think that Einstein's once ridiculed idea keeps Netflix from stuttering. Scientists still argue whether our increasing reliance on time as a tool will eventually show us where the seams in physics really are. If relativity begins to fray, at some extreme near black holes, or at quantum scales, it might reveal itself first in our technologies. Imagine a future where your phone tells you not just that your GPS is drifting, but that the laws of space-time are slightly off today, like the universe forgot to wind its watch. Another frontier, quantum clocks. Built not on vibrating cesium atoms but on the delicate oscillations of ions and photons, these clocks promise precision so absurd they could measure the difference in time between the top and bottom of a coffee mug. One day, such devices might let us map Earth's gravity field in real time, spotting subterranean rivers or monitoring volcanoes. You'd no longer just tell time, you'd use time to scan the Earth like an X-ray. And then there's the cosmic scale. Astronomers turn time into a ruler, measuring the delay of signals from pulsars, those lighthouses of spinning neutron stars to detect gravitational waves. These faint ripples stretch and compress space-time itself, changing the arrival times of pulses by billionths of a second. In this sense, the entire Milky Way becomes a clock, ticking in sync, waiting for disturbances to ripple through. Here's a quirky fact to drift on. Deep in Antarctica, scientists dream of using synchronized clocks scattered across the continent to listen for echoes of neutrinos, ghostly particles that sail through planets like arrows through mist. They hope these timestamps will reveal cosmic events long before telescopes can. In other words, time becomes not just a measurement but a messenger, whispering about things we cannot yet see. And of course, your own body carries its tiny toolkit of time distortions. Every heartbeat, every blink, is part of the clockwork that evolution tuned. But as technology sharpens our clocks beyond what biology ever needed, we start to wonder, are we outpacing nature's design? Maybe. Or maybe we're aligning ourselves with a truth the cosmos has always known, that time is both elastic and useful, a currency we can save, spend, and, at least in a sense, earn interest on. So tonight, when you let your thoughts wander, imagine this: humanity, tiny specks drifting in an ocean of stars, quietly rewriting the rules of time. From pizza deliveries to particle lifetimes, from the hum of satellites to the whisper of galaxies, we've taken something immeasurable and turned it into a tool. And while scientists still argue about the fine print of reality, you live every day in a world calibrated by relativity, a world where time is not just endured, but engineered. And perhaps that's the most poetic truth of all. In learning to bend time, you discover that time has always been bending for you, patiently, invisibly, keeping pace as you stumble forward into tomorrow. Imagine you're sitting right where you are now, comfortable, cozy, the faint hum of the room around you. To you, this is now. But across the universe, in a galaxy 2 billion light years away, another being might be sipping something warm, also convinced it's now. The twist? Physics tells us there's no universal now that links you and them. The very idea of a shared present moment is an illusion stitched together by perception, not by reality. This is where time dilation and relativity get more personal, because it isn't just about clocks on satellites or particles in colliders. It's about the structure of time itself, how your timeline is yours and mine is mine, and the cosmos never signed off on synchronizing them. When Einstein published special relativity in 1905, one of the most unsettling consequences was this: simultaneity is relative. Two events that appear to happen at the same time for one observer may happen at different times for another, depending on motion. That birthday candle blowing out on Earth? It might align with a meteor passing a distant star in your frame, but for someone else zipping past at half the speed of light, the candle and the meteor are separated by years. Scientists still argue whether the present exists at all as a slice of the universe, or whether time is more like a loaf of bread, with all moments past, present, future, coexisting, waiting to be experienced depending on where you cut. This block universe view suggests that what you call now is simply the place you're standing in the loaf, while someone else's now is a different slice. There's no master knife cutting one cosmic sandwich for all. Quirky tidbit: trains were the first battleground for simultaneity. In the 19th century, before relativity, people struggled to synchronize clocks for rail schedules. Telegraphs helped, but Einstein himself grew up near Swiss train stations, pondering what it meant to declare two clocks in sync when signals took time to travel. He later imagined lightning strikes hitting both ends of a moving train. To a passenger, the strikes seemed uneven, while to a bystander on the platform, they seemed simultaneous. That thought experiment shattered the illusion of a single universal now. You live the consequences daily without noticing. GPS satellites don't just correct for gravity, they also correct for the fact that you're now on Earth, and their now in orbit don't align perfectly. If they didn't, your navigation would be off by kilometers. Think of that next time your phone cheerfully directs you to a coffee shop. It's bending multiple timelines into one coherent map, so you don't end up in a river. And the deeper you lean into this, the stranger it gets. Philosophers sometimes argue that if simultaneity is relative, then concepts like the present moment are just convenient illusions for brains that can't handle the cosmic sprawl. You experience your timeline as flowing, but physics suggests it may already be written past, present and future, coexisting like a film reel. You're just moving frame by frame. Of course, you might protest, but I feel the present. I experience now. True, but feelings aren't physics. And yet they matter, because the entire human story, love, grief, ambition, regret, unfolds inside this illusion. If there is no universal now, your life becomes an exquisite local event, bound to your personal trajectory through space-time. And that's oddly beautiful, isn't it? It means your now is yours alone, not shared, not diluted. It's as unique as a fingerprint, carved by your speed, your gravity, your path. You're not floating in some grand universal clock, you're carrying one inside your very being. Think of the way people talk about being in the same moment. Two lovers separated by oceans whisper goodnight across a phone line, both convinced they are sharing a single instant. Yet physics reminds us this is only an approximation. The signals between them are delayed, the rotation of Earth subtly shifts their clocks, and satellites overhead are busy correcting for relativity so their voices align. Their sense of now is fragile, stitched together by technology and perception, not by some cosmic metronome. This isn't just poetic abstraction, it has measurable effects. In particle accelerators, protons whirling at near-light speeds experience different slices of simultaneity. What seems to happen together in the lab might not be together in the proton's frame, and when we detect gravitational waves, the ripples arrive at observatories that must coordinate across Earth. Without careful correction, one facility's now could be milliseconds off from another's, which in cosmology is the difference between clarity and chaos. Mainstream fact: relativity insists simultaneity is relative, tested again and again with precise clocks flown on airplanes, mounted on satellites, or compared across long baselines. The Hafele-Keating experiment in 1971 flew atomic clocks around the world, and when they returned, their readings no longer matched those left on the ground. That difference wasn't a malfunction, it was reality's way of showing us now doesn't exist universally. Quirky tidbit: there's a small community of philosophers who insist we should abandon the word now entirely in physics and replace it with local time slice. Imagine how cold that sounds in everyday life. Instead of asking, "What are you doing now?" you'd have to ask, "What are you doing in your personal time slice relative to my inertial frame?" Date nights would never survive. Scientists still argue whether the block universe model is correct. If it is, then all events past, present, and future are equally real, and what we call the flow of time is just consciousness moving along a pre-written path. Others argue for presentism, the idea that only the present is real, yet relativity leans toward the block view, where now is not privileged. Which one is true? No consensus exists. You can see how this bleeds into philosophy. If your now is yours alone, then the universe is a quilt of private moments, none more real than another. That means your existence is stitched into space-time permanently. You can never be erased. The laughter you shared 5 years ago still exists in another slice of the loaf. The future version of you already exists too, waiting in another frame. You're not marching through time, you're embedded in it. And here's where the strangeness becomes comforting. You've probably mourned that moments slip away forever, but if the block universe holds true, nothing actually vanishes. Your childhood, that sunrise you once watched, the words you spoke today, they're all carved into space-time, like grooves on a vinyl record. You only play one track at a time, but the whole album is there. There's a practical side too. The absence of a universal now makes futuristic technologies like near-light speed travel even stranger. If you zipped off to a distant star and back, not only would you return younger than your friends, time dilation again, but the definition of now you carried with you would diverge from theirs. When you ask, "What's happening on Earth right now?" relativity shrugs, it depends on how you move. And here's a sly joke the cosmos likes to play. Every time you sync your phone, you're quietly forcing multiple nows into agreement. Without engineers bending relativity to their will, your maps would fail, your bank transfers wouldn't line up, even your morning coffee order might get lost in temporal translation. You live in a world where simultaneity is an illusion that we patch together with algorithms. Pause and imagine this. All across the world, people are going to bed, waking up, laughing, grieving, falling in love, all in their own time slices. None of these moments share a universal now, yet they coexist in a lattice of relativity. The universe doesn't care about a synchronized clock, but the human heart still insists on togetherness. That stubborn insistence is its own kind of beauty. So the next time you say, "right now," remember you're claiming something physics denies, yet don't let that unsettle you. Instead, let it add depth to the moment. Your now is yours alone, a private thread in space-time, but by speaking, listening, and connecting, you weave it into others. That weaving may be the closest thing to a universal present we'll ever create, a handmade illusion, fragile and fleeting, but precious because of it. And as you breathe in this thought, you can almost feel the paradox. You are in your now, I am in mine, and somehow, against the rules of relativity, here we are sharing it. You've probably daydreamed about time travel, stepping into some humming, glowing contraption and emerging in another century. But the truth is, you don't need a machine. Time travel is already written into the physics of speed. The faster you move through space, the slower you move through time. It's not science fiction, it's the everyday reality of relativity. Picture yourself boarding a spacecraft, sleek and silent, engines primed to push you toward the speed of light. From your perspective inside, everything feels normal. Your coffee still cools in minutes. Your heart still ticks along at its usual rhythm. Your favorite playlist still loops in the background. Yet to anyone watching from Earth, you've slipped into slow motion. Your heart beats more slowly, your coffee cools more slowly, your entire life is dragging compared to theirs. You're time traveling not by jumping into the past, but by bending the future toward yourself. Mainstream fact. This is time dilation in its purest form. At speeds approaching light, seconds for you stretch into minutes or hours for someone at rest. Experiments confirm it. Particles called muons, created in the upper atmosphere, should decay in millionths of a second. Yet because they travel close to light speed, they live long enough to reach Earth's surface. Without relativity, they'd vanish before arriving. Their survival is a postcard from the future, proof that speed bends time. The quirky tidbit: if you really wanted to meet the future you, one trick is to hitch a ride on one of those muons. Imagine shrinking yourself down, clinging to its little particle shoulders, and surfing it through the atmosphere. You'd blink, and by the time you let go, the Earth below would have aged thousands or millions of times more than you did. The muon might not appreciate the company, but you'd have pulled off a cosmic magic act, leaping into tomorrow without a time machine. Scientists still argue whether this makes time travel real. Some say it's just a mismatch of clocks and illusion of frames. Others insist it's genuine. The traveller has less time between events than the observer, and there's no absolute perspective to correct it. Both sides agree, though, that if you can get close enough to light speed, you can launch yourself forward in time. The only limitation is the brute physics of acceleration and energy. Now imagine the implications for space travel. Say humanity builds a ship that can cruise at 99.9% of light speed. You hop aboard, wave goodbye, and head toward a star 100 light years away. For Earth, that journey will take a century. For you, tucked inside your relativistic cocoon, the trip might feel like a few years. When you arrive, your grandchildren's grandchildren's grandchildren will be waiting if humanity is still there to greet you at all. You will have outpaced their calendars simply by moving fast. This reshapes how we think about interstellar exploration. Our galaxy is impossibly vast. Even at light speed, crossing it would take 100,000 years. But relativity is sneaky. The faster you go, the more time you steal for yourself. For the traveller, the distance shortens, the decades compress. That means it's not utterly impossible for future civilizations to visit distant stars. It just means they'll return to an Earth profoundly changed, if it exists at all. You might laugh here and think, well, great, so I can go see the Andromeda Galaxy, but by the time I get back, everyone I know will be dust. That's exactly the catch. Relativity is a one-way ticket into the future. There's no shortcut to come back and wave from the past. You're not Marty McFly returning to the 1982nd, you're the astronaut aging in slow motion, coming home to a planet that has raced centuries ahead. Still, this isn't just theory. Astronauts aboard the International Space Station live it daily. Their orbits are fast enough that time ticks a hair slower for them than for people on Earth. After months, the difference is tiny fractions of a second. But it's there. Each astronaut is a living proof that time isn't rigid. It bends to speed. And here's a fun modern aside. If you really wanted to get technical, you already time travel every time you get on a plane. At 900 kilometers per hour, your body ticks slightly slower than your friends back home. By the end of a long-haul flight, you've traveled a few nanoseconds into the future. Not much to brag about, unless you want to irritate friends by insisting you're technically older than them by fewer seconds than it takes to blink. Now let's go deeper. Imagine you keep pushing your ship faster, closer to light's edge. At 99.999%, Earth's centuries shrink to years for you. Push further, To 99.999999%, an entire millennia could pass outside while you flip through your onboard novel. You'd skim across space-time like a stone over water, skipping ahead in history while barely aging yourself. This brings up the terrifying beauty of relativity. There's no absolute wall between today and tomorrow. There's only how you move through space-time. Your motion decides your path, your clock, your private universe. Everyone else has theirs. Time is not a river we all float down together. It's an ocean where each of us swims in a slightly different current. Let's add one more mind-twisting element. From Earth's perspective, your ship can never quite reach light speed. The energy needed rises toward infinity, like climbing a mountain that keeps growing as you climb. But from your perspective inside the ship, distances are shrinking. The star you thought was 100 light-years away is now only a few light-years in your frame. You're not breaking light's rule, you're bending reality's ruler. There's humor hidden in this. The universe is basically saying, you can't outrun light, but you can cheat by shrinking the finish line. It's like telling someone they can't eat the whole pizza. So they fold it in half and suddenly it looks manageable. Space-time has its own sense of cosmic irony. And then comes the paradox we love to wrestle with. If you keep going far enough, does this mean you could travel so fast that you see the end of the universe before your coffee gets cold? Some scientists argue, yes, you could witness the death of stars, the fading of galaxies, even the dark silence of heat death, all while living a human lifespan. Others argue no, energy limits will always stop you short. The debate is alive, unsettled, and deliciously strange. But regardless of limits, the lesson is clear. You don't need a glowing DeLorean to time travel. You just need speed, patience, and a willingness to leave everything behind. The future is waiting, written into the equations, and all it asks is that you press the accelerator. You picture yourself back inside that imaginary starship, engines whispering as you slip further and further toward light's barrier. The windows no longer show the stars as you once knew them. They've bunched together, squished forward in your field of view, their colors stretched and shifted. Behind you, the universe seems to glow faintly red, light stretched thin into longer and longer wavelengths. Ahead, everything sharpens to a fierce blue glare. You've entered the strange optical funhouse of relativity. This isn't just a thought experiment. Pilots and astronomers already know what this looks like. Even at a fraction of light speed, the stars shift slightly. At higher speeds, the starlight itself compresses into a cone in front of you, as though the whole universe has been drawn into a tunnel. You don't just move through space, you warp the very sky. It's a reminder that time travel by speed isn't just about clocks, it's about perception, about how reality itself tilts to accommodate your motion. Mainstream fact: astronomers measure this effect in the light from galaxies racing away from us. It's called redshift. Their light is stretched as space expands, slowed and smeared by cosmic distance. The same principle plays out in your ship. Velocity squeezes and stretches light, turning the universe into something new depending on how you move. Quirky tidbit: if you ever wanted to watch an entire series of your favorite show while traveling near light speed, you could actually fast forward the outside world. A sitcom that aired weekly for 30 years. From your seat, you'd age only a handful of years while every episode aired, reran, and aged into nostalgia for the people back on Earth. You'd come home a living spoiler. Yes, I know how it ends, but trust me, you don't want to wait 30 years for the finale. Scientists still argue whether this kind of time travel is the real deal or just semantics. Some point out that the traveller and the observer both age, both live complete lives. It's just that their timelines diverge. Others say that if you can return after centuries while having aged only a few years, you've genuinely moved into the future. The arguments are less about physics than about philosophy. What does it mean to travel in time if every frame is equally valid? And then, of course, comes the emotional weight. Imagine you've gone on such a journey. You leave behind friends, family, the streets you know, the songs on the radio. To you, you'll be back in a few years. To them, you'll be a legend, a ghost, a relic of a bygone age. They'll live entire lives, generations will rise and fall, while you glide in silence across the cosmos. When you step back onto Earth, nothing will be familiar. You will be a visitor from the past, still young, still carrying memories that no one else shares. This is the bittersweet heart of relativistic time travel. It's not just physics, it's loneliness dressed as science. The universe gives you the gift of longevity, but it demands everything you know in return. Still, think about the possibilities. Interstellar missions might not require cryogenic sleep or genetic tinkering. Relativity itself could carry the crew across impossible distances. To them, the trip might be a career's worth of years. To Earth, it would be centuries. Civilizations might rise and fall in their absence. This could make exploration viable in a strange, one-way sense. Humanity would scatter like seeds, each ship's crew stepping off into the future far beyond their starting point. Let's inject a touch of humor here. Imagine astronauts making TikToks on board. "Hey guys, just checked. We've been gone 3 weeks, but apparently Earth is now ruled by talking dolphins. Drop a comment if your ancestors remember us." It's absurd, but it highlights something sobering. Relativity isn't just math. It's culture shock, time shock, history shock. Now let's stretch this further. Suppose you build a ship capable of circling the galaxy at near light speeds. You could, in theory, lap the Milky Way while aging a few decades, while outside billions of years passed. You'd return to find the galaxy utterly changed. Stars burned out, constellations warped beyond recognition, civilizations either ascended, fallen, or vanished. You'd be the ultimate time tourist, the galaxy's before and after picture in human form. And here's a fringe thought worth savouring. Some theorists wonder whether consciousness itself plays a role in how we perceive time dilation. Is time a flow, or is it just our brains stitching together events? If it's perception, then speeding up might not just bend physics but alter experience itself. What would it feel like to live in slow motion relative to everyone else? Would conversations drag? Would music stretch? Or would your brain, your inner metronome, tick at the same pace regardless, leaving you blissfully unaware of the cosmic cheating you're pulling off? Scientists still debate whether time is a fundamental property of the universe or an emergent one, a side effect of entropy, memory, or causality. Time dilation doesn't answer that, it deepens the mystery. If time can bend and stretch, maybe it's not as solid as we think. Maybe it's more like a stage curtain billowing, folding, rippling while we play our roles behind it. So where does this leave you, the would-be traveller? You don't need to imagine wormholes or paradox machines. You just need speed, endurance, and the courage to leap forward without looking back. Time travel isn't about breaking rules, it's about playing within them so cleverly that the rules themselves deliver you into tomorrow. And when you realise that, you see something almost comforting. You're already time travelling. Every second, you're being pulled into the future, carried along at the universal pace of causality. Relativity just gives you the option to turn the dial, to skip ahead, to bend your personal line a little more steeply. You may never have a shiny flux capacitor humming in your garage. But the real magic is stranger. The universe itself is the time machine, and every rocket, every particle, every heartbeat is already along for the ride. You don't need a spaceship screaming toward the stars at near light speed to experience time dilation. In fact, you're living it right now, right where you sit, without even noticing. Your body is a quiet laboratory of relativity, and the clock inside you ticks just a little differently depending on where you stand. That's because gravity itself shapes time. Einstein showed us that the stronger the pull of gravity, the slower time runs. The closer you are to Earth's core, the more space bends, and the slower your seconds stretch. You, sitting here with your feet on the floor and your head a metre or two above, are actually split between two timelines. Your toes are aging slightly slower than your scalp. The difference is microscopic, but it's there, measurable and undeniable. Mainstream fact: in 2010, physicists at the National Institute of Standards and Technology used two of the world's most precise atomic clocks to prove this. They placed one clock just 33 centimeters higher than the other. The elevated clock ticked faster. In other words, if you spend your life living on the second floor of a house rather than the basement, you'll be older by a few nanoseconds than your downstairs neighbour. That's relativity hiding in your living room. Now imagine stretching that difference over lifetimes, across landscapes, between planets. The same principle means astronauts orbiting above Earth age just a little faster than people on the ground, since they're farther from Earth's gravity well. But they're also moving at high speeds, which slows them down. It's a cosmic tug of war, with velocity pulling one way and gravity the other. The winner depends on altitude, orbit, and speed, all combining into a subtle dance of seconds. Quirky tidbit: if you could stand on the surface of a neutron star, a place where a teaspoon of matter weighs billions of tons, your time would slow to a crawl. A single heartbeat of yours would stretch into long minutes for someone watching from far away. The gravitational field is so intense that the fabric of time itself clings to the star, refusing to let go. You'd effectively be frozen from the universe's perspective, like a character trapped between frames of film. Not that you'd survive the experience. The tidal forces would pull you apart long before you had time to notice. Scientists still argue whether this gradient of time in your body is simply a curiosity, or whether it hints at deeper truths about consciousness and existence. Does the brain, stretched across slightly different time zones from skull to toe, experience anything unusual? Probably not. The differences are far too small. But it makes you wonder, could a hypersensitive being, or some alien life form tuned into space-time itself, perceive these gradients? Could they hear the difference in the ticking of time between your heart and your head? You picture yourself lying in bed. Your feet are anchored down, your head on a pillow. Night drifts around you. Somewhere inside, atoms tick their rhythms, the clocks of nature marking each fraction of a second. But they're not ticking in perfect unison. Down by your toes, they're imperceptibly delayed. Up near your skull, they're ever so slightly ahead. You are not one timeline, but a thin smear of many, stitched together so seamlessly that you call it now. There's a strange comfort in this, almost like being stretched across the flow of time. You are not simply living, you're already participating in a cosmic experiment. The Earth beneath you warps space-time, and your body rides the gradient like a surfer on an invisible wave. Humor has its place here too. If you really want to live longer, don't waste money on anti-aging creams. Just lie down flat, put your head on a pillow, and keep your feet propped high. Technically, your head will age faster than your feet, so why not flip upside down for a while? You'll gain a few trillionths of a second, just enough to say you beat time at its own game. Still, the idea grows heavier the more you think about it, because if such small differences can be measured in your body, what does that mean for mountains, skyscrapers, or entire planets? The summit of Mount Everest lives in a slightly faster future than sea level. If you lived your life at the top of Everest, you'd age faster than those who lived at the beach. Over eons, civilizations perched high above might live in subtly accelerated time compared to those below. Could this, in some bizarre way, shape history itself? Scientists still debate whether these tiny relativistic shifts, accumulated over geologic time, might influence evolution, geology, or even the rhythms of climate. Most say the effect is vanishingly small, but still it's there. The Earth is not a single clock, but billions of clocks, every height, every depth, every spin slightly out of sync. And you, in the middle of it all, are proof. The gradient of time in your body is tiny, too small for you to feel, and yet, the universe never wastes a principle. These small wrinkles in time are like whispers of something bigger. If your head and feet already disagree on how fast time passes, what happens on the scale of planets, stars, or galaxies? Imagine the International Space Station gliding above the Earth. Astronauts there orbit hundreds of kilometers higher than you. From their vantage point, gravity's grip is weaker, so their seconds move faster. At the same time, they're moving at about 28,000 kilometers per hour, which slows them down. Add these effects together, and astronauts experience time just a little differently than those on Earth. After a 6-month mission, the difference is only milliseconds, but it's measurable. When they return, their clocks disagree with the ones on the ground. That disagreement isn't a mistake. It's the truth of the universe, written into their bodies. Now, scale this idea up. On Earth, every mountain, valley, and skyscraper is its own laboratory of relativity. Your watch at the top of a skyscraper ticks faster than one in the basement. The people on airplanes flying overhead live in slightly quicker time than those below. Global Positioning System satellites orbit far enough above Earth that they need corrections for both gravity and speed, or else their maps would drift kilometers off course each day. When you check directions on your phone, you're really holding a device that negotiates the nature of time itself, syncing with machines orbiting in subtly different futures. There's something deeply humbling about realizing that time is not a flat canvas stretched equally over all of us. Instead, it's sculpted, molded, and warped by both motion and mass. Even within your body, your atoms don't agree perfectly on the pace of their existence. You are stitched together by relativity. And then there are the extremes. Near the surface of a black hole, the time gradient becomes nearly infinite. If your feet dangled closer to the event horizon, while your head remained higher, the difference in time would tear you apart, literally stretched into spaghetti by the uneven pull of gravity and the mismatch of seconds. This spaghettification is the gruesome but mathematically precise name scientists give to the fate of anything unlucky enough to fall into a black hole. But here, in your safe, earthly body, the stretching is gentle, imperceptible, just enough to remind you that you're part of the cosmic story. Scientists still argue whether this subtle bending of time has broader meaning. Could these gradients influence the brain? If neurons in your head exist in a slightly faster frame than blood circulating in your feet, does consciousness integrate across timelines? Most say no again. The difference is too minuscule. But physics has a way of turning too small to matter into breakthroughs. After all, the entire field of quantum mechanics began when scientists noticed that energy levels didn't behave quite as expected. Who's to say time gradients in the body aren't a clue to something waiting to be discovered? You can try a thought experiment. Imagine lying completely still, stretching out on the ground. You are perfectly aligned with Earth's surface. Even so, your body spans a gradient of time, each centimeter slightly different. You close your eyes and pretend you can feel it. Maybe your feet hum a lower note, while your head whispers a higher one, together forming a chord you can't consciously hear but that resonates in the universe. You are a symphony of seconds. And here's the cheeky part. If you're looking for the ultimate anti-aging hack, just live in a basement your whole life. Technically, you'll age a smidge slower than your upstairs neighbours. Over billions of years you might gain a whole extra second. Not the most practical self-help tip, but it makes a good party fact if your parties are the kind where relativity comes up between the chips and dip. But pull back from the humour, and the lesson lingers. Time is not uniform, even within you. It flows differently for every part of your body, depending on its place in the Earth's gravitational field. The cosmos has woven relativity into your flesh, into your bones, into every breath you take. You are not just a being in time, you are a gradient of time, a living slope carved across the fabric of space-time. And perhaps that's the deepest truth hiding in the quiet difference between your head and your feet. The universe doesn't just bend far away, in galaxies or around black holes. It bends here, in you. Every second you live is a reminder that Einstein's cosmos is not an abstract theory but a presence inside your skin. Time dilation isn't a distant concept. It's the way you exist. You've heard the whispers before that black holes are not just cosmic drains, but possible time machines. And while the phrase sounds like it belongs more to the pages of science fiction than the equations of physics, the strange thing is this: Einstein's universe doesn't forbid it. In fact, when you look closely at how space-time behaves around a black hole, you find the seeds of something extraordinary: time itself, slowing, bending, and stretching until the future and the past become almost negotiable. Picture yourself orbiting close to the edge of a black hole, not inside the horizon where nothing can return, but just outside, dancing on the razor-thin edge where physics still allows you to hover. To a distant observer watching from safe ground, your clock runs unbearably slow. If you circled for a year and returned, you might find that centuries had passed for those who stayed away. You would have taken a one-way trip into the future, using nothing more than gravity's merciless patience. This is the first way a black hole becomes a time machine, not by rewinding your life like a cassette tape, but by dragging your seconds so sluggishly that you leap ahead of everyone else. And it's not fiction. This is a mainstream, measurable prediction of relativity. Scientists still argue whether practical journeys like this could ever be attempted, but the principle is as solid as the math that keeps satellites working above Earth. But time travel stories always crave something more dramatic. What about the past? Could a black hole bend reality so tightly that paths loop backward, allowing you to arrive before you left? The answer, teased out of equations like the Kerr solution for rotating black holes, is a mischievous maybe. If a black hole spins fast enough, it doesn't just curve space-time, it twists it, dragging everything around like water in a whirlpool. Inside this dragging, there could exist closed time-like curves, routes through space-time that circle back on themselves. To travel along one would mean meeting your younger self, an echo of yesterday folded into today. Of course, that's where paradoxes rear their mischievous heads. Could you shake hands with yourself? Could you whisper tomorrow's lottery numbers into your own ear? Physicists play with these puzzles, not because they expect anyone to build a black hole DeLorean, but because the mathematics forces them to confront how fragile causality might be. Stephen Hawking himself once proposed a chronology protection conjecture. The universe, he suggested, finds ways to censor paradoxes to prevent time travel loops from ever being stable enough to exist. Maybe the tiniest quantum jitters would tear the loop apart the moment it tried to form. Still, the thought lingers. Black holes may be windows not just into the deep future, but into the structure of reality itself. They test whether time is a river that only flows one way, or if it's a vast ocean with eddies, whirlpools, and hidden shortcuts. And while you can't yet book a trip to orbit a black hole, and honestly, you wouldn't survive the trip if you could, the idea leaves you staring upward, imagining. The stars around you shimmer, and you realize that above every black hole in the night sky, silent, invisible, waiting time itself is playing a trick, slowing, stretching, promising futures far stranger than the present. Imagine yourself drifting closer to the edge of one of these cosmic giants, the black hole spinning with an almost arrogant velocity. The mathematics of the Kerr solution tells you that not all black holes are equal when one rotates. It warps the stage more violently, pulling time and space into a dance that doesn't just flow inward, but swirls sideways, like cream stirred into coffee. You don't just fall down, you're dragged around, inescapably, even if you wanted to resist. Now, think of riding that swirl, letting the black hole spin carry you. Theoretical physicists point out that such motion could, at least in principle, lead you along paths that loop through time. These aren't mere flights of imagination. They emerge from equations, uninvited and uncomfortable. Closed time-like curves, they're called, trajectories through space-time that don't head into tomorrow or fade into yesterday, but instead circle around, depositing you back at your own starting point. If that sounds suspiciously like the definition of a time machine, well, that's exactly why it unsettles people. To grasp how alien this would feel, imagine carrying a notebook on such a journey. You jot down the date and time, your hand trembling in the warped light. Then, after hours or minutes, or whatever clocks mean in such places, you find yourself back where you started, notebook still in hand. Flip the page, and the first entry stares at you, but it is your handwriting from before you arrived. Time has betrayed you, folded itself, and left you doubled. Of course, reality checks abound. To even survive near a rotating black hole, you'd need technology beyond our wildest projections. Starships that could resist tides strong enough to spaghettify entire moons, shielding against radiation that could fry electronics before you even finished a sentence. And then there's the quantum question. Could space-time tolerate such loops, or would the jitter of quantum fields destabilize them instantly? Hawking thought so. His chronology protection was like the universe's immune system, rejecting any attempt at paradox. Scientists still argue whether such a defense mechanism is inevitable or merely wishful thinking. But even if closed time-like curves never stabilize, the forward time travel aspects of black holes are beyond dispute. The Event Horizon Telescope, capturing the shadow of M87*, wasn't just photographing light trapped at the edge of a black hole, it was peeking at a realm where time itself is stretched like dough. Any astronaut foolish or brave enough to orbit near that abyss would return to find civilizations risen and fallen while only months passed in their own bones. That future leap is perhaps the most practical and terrifying use of a black hole time machine, not the chance to rewrite history, but the temptation to escape it. Imagine a starship circling a supermassive black hole in Sagittarius A, waiting out a cosmic storm, or perhaps skipping through centuries of human strife in the blink of a personal eye. You'd pay with isolation, with the ache of returning to a world you no longer recognize, but relativity doesn't much care for feelings. The equations are ruthless. And yet, there's something hauntingly beautiful in the idea. The universe, usually so unyielding, offers here a loophole, a way to cheat the flow of time, not by breaking its rules but by obeying them so strictly that the rules themselves twist into something stranger. You can almost hear the quiet hum of the cosmos saying, yes, Time travel is possible, but only if you're willing to sacrifice everything familiar. You lean back, picturing the black silhouette of a hole against the trembling light of the galaxy. You imagine circling it, watching the stars race ahead, their patterns shifting, constellations dissolving into unfamiliar maps. Each orbit would be a heartbeat in your chest, but a millennium to the civilizations you left behind. You'd become a visitor from the past, not through magic, but through the very architecture of space-time. And maybe, just maybe, that is enough to call black holes time machines. Not the kind that let you shake hands with your great-grandparents, but the kind that remind you that time is not absolute, not universal, not safe. It bends, it stretches, it conspires with gravity to play tricks so profound that even the most serious scientists sometimes sound like poets when they try to explain it. You can't help but smile. The black hole is still terrifying, yes, but in its shadow, you glimpse the possibility that time is not a cage, but a canvas, and that even the darkest corners of the cosmos might let you paint something unexpected on its surface. You close your eyes and imagine light, not the kind spilling lazily from your bedside lamp, but the raw, perfect kind that streaks across the cosmos, carrying with it the oldest stories in existence. A photon, born in the heart of a star, doesn't know what waiting feels like. It doesn't know what it means to age. For light, the moment it is created and the moment it is absorbed are one and the same. No ticking clock, no in-between, just an eternal present stretched across unimaginable distances. And that's the strange, beautiful truth. Light does not experience time at all. In the language of relativity, photons move at the universal speed limit, the speed of light, and because of that, their personal clocks stand still. From your perspective, a ray of sunlight takes about 8 minutes to travel from the sun to your eyes. From the photon's perspective, that journey is instantaneous. There is no before and after, only the eternal now. It's unsettling if you think too long about it. You live your life chained to time's relentless current, second after second, heartbeat after heartbeat. But light glides entirely outside the river, never dipping a toe in. Imagine a traveller who could sprint so perfectly fast that they skipped the flow of time altogether. That's what every photon is doing, silently, ceaselessly, without ever once stopping to look back. This peculiarity changes how you think about cause and effect. When you gaze at a distant galaxy whose light has been travelling toward you for billions of years, you feel as though you're peering back in time. But for the light itself, no journey happened. It was emitted, and then it arrived instantaneously. You, the slow observer, stretch the path into eons. The photon doesn't notice. And so, each night sky is a paradox, an ocean of ancient messengers, none of which ever experience the passage of time they are supposed to represent. You're staring at the ghosts of the universe, but from their perspective, they never even lived long enough to become ghosts. They are forever in the moment of their birth. You roll this around in your mind, and it makes you laugh softly. If photons could talk, would they complain about how boring it is to exist without time? Or would they pity you, trudging through the thick syrup of seconds, while they skate effortlessly across the void in a single timeless instant? Maybe they'd say, "Relax, you're overthinking it. Everything is now." The implications ripple outward. If light never ages, then every photon you see is as fresh as the moment it was born. The sunlight warming your skin this morning is as young as the instant it escaped the nuclear furnace of the sun's core. The starlight twinkling tonight is as young as the moment those stars first flung it outward, even if it has been racing toward you since before Earth's continents found their current shapes. And here's a quirky tidbit. Photons are massless, yet they carry energy and momentum. They are like the ultimate minimalist travelers, no baggage, no weight, just pure motion. You, with your bones and your breath and your tendency to trip over furniture in the dark, are bound by inertia. But photons? They're the universe's pure nomads, free from the burden of mass, free from the shackles of time. Scientists still argue whether photons even exist in the way we think. After all, if they experience no time, can we really say they have a journey at all? Are they particles at all, or waves, or something stranger? Something that only becomes real when you finally look at them. Quantum mechanics suggests that until measured, they are smeared across possibilities, neither here nor there, neither this nor that. And yet, every time you switch on a lamp, the room floods with certainty. Reality seems to wait until the last possible moment to make up its mind. And so, as you lie there, imagining photons streaking silently through the cosmos, you realize that light is not just illumination, it's a lesson, a reminder that time itself is not as universal as you once believed. For you, it is a river. For light, it is an illusion. And in between those two truths is a mystery large enough to keep physicists awake at night, even as you, hopefully, drift a little closer to sleep. You turn the idea of timeless light over in your mind again, like a pebble warmed by the sun, smooth and strange. You, a creature who cannot escape time, are trying to imagine what it means to exist outside of it, and the more you try, the slipperier it becomes. Your life is a long chain of moments, each one linked to the next. But for light, there is no chain. There isn't even a single link. There is only presence, infinite and indivisible. Think of a candle flame. The glow feels soft, almost delicate, yet in those gentle rays are photons that travel at the same unyielding speed as the gamma rays unleashed by the most violent supernovae. Whether born in fire or fury, whether traversing your living room or spanning 10 billion light years, they all share the same peculiar condition. No aging, no waiting, no unfolding. It's almost as though light holds up a mirror to you and whispers, "You think time is absolute, but maybe it's only your prison, not mine." That whisper rattles you, because if light is untouched by time, then the universe's most important storyteller doesn't experience the story at all. You rely on light to know everything beyond your fingertips, every star, every nebula, every galaxy. And yet, the messenger never experiences the journey. You are left holding fragments of truth from a courier that never knew it was delivering anything at all. Here's a playful thought. Imagine a photon slipping out of the sun's fiery core. From your perspective, it might take thousands, even millions of years for that photon to fight its way through the dense solar plasma before finally escaping into space. Then it glides the remaining 93 million miles to Earth in just over 8 minutes. But if you were that photon, there would be no millions of years. The instant you were born, you were already here, in the blink of eternity. From the photon's perspective, the sun and Earth collapse into a single point. The whole arduous journey dissolves into an instant. This collapse of distance and duration is not just poetic, it's built into the mathematics of relativity. Time and space are not fixed backdrops. They flex and twist depending on how fast you move. And if you move at light speed, time collapses to zero and distances shrink to nothing. For you, the cosmos is unimaginably vast. For light, it has no width at all. There's a quirky side to this too. In a sense, photons could be thought of as the ultimate multitaskers. They don't bother with before or after. They don't worry about where either, since space collapses along with time. To them, emission and absorption are just one seamless event. In their timeless existence, the universe is less a vast expanse and more a single eternal flash. And yet, this defies your intuition so much that your brain rebels. You want to ask, how can something exist and not experience time? Doesn't existence require duration? But maybe that's just a bias born of being human. You only know existence through change. You grow, you breathe, you age. But photons embody a form of being that is utterly alien to you, unchanging, eternal, without a clock in their pocket. This perspective has strange philosophical consequences. If light never experiences time, then in a sense, all events in which light is involved are connected instantaneously. A photon created in a star that died before Earth was born and absorbed in your eye tonight, from its perspective, those two events are one. You are entangled, through that particle of light, with the ancient furnaces that forged the elements of your own body. It's not just metaphor, it's physics, whispering that the past and the present may be closer than you think. Scientists still argue whether photons should even be said to exist in the normal way between emission and absorption. Some argue that they are not real in the classical sense until they interact with something. Others push back, insisting that photons must exist as quanta of the electromagnetic field, even if their journey through space-time is peculiar. And so, in laboratories and conference halls, the debate continues. Is light a true traveller, or merely a bridge between moments? Meanwhile, you lie back and smile at the thought of your bedroom lamp, casting little packets of eternal presence into the air. They bounce around your walls, reflect in your mirror, scatter off your bedsheets, and to each of them, it's all instantaneous. If you were a photon, you'd have no patience for waiting on hold or queuing for coffee. You'd simply appear, forever punctual, in every place at once. Of course, your own life doesn't work like that. You must rise each morning, feel hunger, measure years, but knowing that light lives outside this rhythm puts your struggles in a new perspective. Your worries, your appointments, your ticking clock, they're all artifacts of being slow. Light, rushing timelessly, invites you to loosen your grip on urgency. If even the universe's most fundamental messenger has no use for time, maybe you can let a few moments slide without counting them so anxiously. You breathe, slowly, as if trying to catch just a glimmer of that timeless calm, and as you do, the stars above seem to shimmer with new meaning. They are not just distant suns. They are mirrors reflecting a truth stranger and deeper, that not everything is chained to the flow of seconds. Some things stand outside the river, untouched, eternal, reminding you that the cosmos is richer than your imagination allows. You pause, listening not with your ears, but with your imagination. For most of your life, you've thought of the universe as silent. Stars twinkle in their distant arenas, galaxies wheel in enormous grace, black holes devour their surroundings, all of it unfolding without a sound. But then you realize, sound is only one way to sense vibrations, and vibrations are everywhere. In fact, the universe hums with deeper echoes than your ears can ever capture. You just need a different kind of listening. Gravity, that quiet sculptor of the cosmos, doesn't just tug at planets and cradle galaxies, it also ripples. When great masses move, colliding, spiraling, or tearing through space, they send out waves in the very fabric of space-time. These are gravitational waves, whispers that stretch and squeeze existence itself. And though they move invisibly, they carry with them the story of the most cataclysmic events in the universe. Imagine two black holes circling one another. With each orbit, they stir space-time like spoons in honey. As they spiral closer, the ripples grow wilder, racing outward at the speed of light, washing across the universe. By the time they reach you, they're faint beyond comprehension, stretching your entire body by less than the width of a proton. And yet, with instruments more delicate than imagination, humanity has learned to hear them. The first time scientists caught such a wave was in 2015, when LIGO, the Laser Interferometer Gravitational Wave Observatory, picked up a fleeting tremor. It was the aftershock of two black holes merging over 1 billion light-years away. That signal lasted less than half a second, a faint chirp that rose in pitch before vanishing. But within that whisper was an epochal message. Einstein was right again. Space-time really does ripple, and now humanity could listen to the universe in an entirely new way. You picture those ripples spreading through the cosmos, not as sound but as movement, like invisible tides rolling through the fabric of being. If your body could sense them directly, you'd feel reality itself pulsing beneath you, a rhythm older and grander than any drum. But instead, machines serve as your ears. Laser beams bounce back and forth down long tunnels, cancelling one another in perfect silence until a gravitational wave disturbs them, tilting reality just enough to make the lasers slip out of step. The silence cracks, and the wave is heard. It's a kind of cosmic eavesdropping, like pressing a glass to the wall of the universe. Through it, you learn of black holes dancing, of neutron stars smashing, of titanic events you could never have glimpsed with light alone. And so, alongside telescopes that see, humanity now has observatories that listen. The beauty of it lies in what gravitational waves reveal. Light can be blocked, scattered, or hidden, but gravity cuts through everything. These waves carry the clean, unfiltered truth of violent moments. And because they move at the speed of light but are untouched by dust or gas, they arrive as pristine records of their source. By learning to hear them, you open a new sensory channel into the universe. You think back to the photons you pondered earlier, messengers without time. Gravitational waves feel like their sibling, but heavier, stranger. They are not particles darting through space-time, but the trembling of space-time itself. To detect one is to feel the heartbeat of the universe in real time. Yet here's the quirky twist. The signals scientists detect are absurdly faint. LIGO can measure distortions as small as 1/10,000th the diameter of a proton. That's like sensing the change in distance between Earth and the nearest star, If it's shifted by the width of a human hair, it borders on the ridiculous. And yet, against all odds, it works. Humanity has learned to pluck symphonies from the stillness of the cosmos, like musicians drawing notes from strings no one else believed were vibrating. Of course, scientists still argue about what gravitational waves might reveal in the long run. Could they carry signatures of the Big Bang itself, echoes from the moment the universe first burst into being? If so, they would let you hear not just the story of stars and galaxies, but the birth cry of time itself. Some say yes, others insist it may forever be hidden beneath the static of later events. The debate rumbles on, while the observatories keep listening. You find yourself imagining lying in a field on a warm night, your head tilted to the stars, while beneath the silence your bones and atoms are being stretched and squeezed by faint cosmic tides. You can't feel them, but they are there, washing through you constantly. The Earth is a buoy bobbing on an invisible ocean. Every so often, a wave from some distant collision laps across your world, unremarked but undeniable. It's humbling. You live inside a sea of echoes, always listening even if you don't realize it. And then comes the thought that makes you smile. If gravitational waves stretch and squeeze space, then for a fraction of a second, as a black hole merges signal past through you, your very bed, your pillow, your blanket, your drowsy body was minutely distorted. You've been gently remolded by the cosmos more times than you can count. Forget massages or spa treatments. The universe gives you tiny stretches, courtesy of colliding stars. A cosmic spa, free of charge. But beyond humour lies wonder. By listening to these waves, you are no longer restricted to what shines. You can hear what collides, what dies, what thrashes in the hidden dark. You can glimpse events too obscured for light to escape. A black hole merger, by definition, swallows light whole, yet its gravitational roar cannot be silenced. In this way, listening extends your sight. You are not just a visual species anymore, you are becoming an auditory one, on a scale galactic and beyond. You imagine the universe as a vast symphony hall. Light has always been your primary instrument. Telescopes collect it like microphones, amplifying the shine of stars and galaxies. But what gravitational waves offer is the percussion, the bass notes, the deep drum beats resonating through space-time itself. They don't replace light, they complete the orchestra. And suddenly, the cosmos is no longer silent. Think of the collision of two neutron stars. These are the ultra-dense remnants of stars that once burned bright, then collapsed into spheres only a dozen miles across, yet holding more mass than your Sunday. When two of these objects spiral together, they release more energy in a moment than all the stars in the observable universe emit combined. The crash rings out as gravitational waves, a crescendo so fierce it warps space-time around it. In 2017, humanity caught such an event. And here's the magic. It wasn't just heard, it was seen. Telescopes across the world turned toward the faint flicker of light that followed the birth of gold, platinum, and heavy elements. In a single night, you learn not only that gravitational waves are real, but that the jewelry on your hand was forged in cosmic cataclysms. As you drift deeper into the thought, you realize that listening to time's echo is also listening to your own story. The iron in your blood, the calcium in your bones, the gold in your ring, they were all born in violent collisions now whispering across the universe. Every time a gravitational wave trembles through you, it carries news of the processes that once created you. The universe is talking, and you are one of the words it has spoken. There's a quirky tidbit here too. Gravitational waves don't just come from cataclysms. In theory, the universe's earliest moments should have produced a background hum, a kind of static left over from the Big Bang. Scientists call this the stochastic gravitational wave background, and if it could be heard, it would be the oldest sound in existence, a relic from when time itself began to stretch. Detecting it would be like uncovering the first heartbeat of the cosmos. And yet, scientists still argue whether this background is detectable at all. Some think it is drowned in the noise of countless later events. Others believe advanced instruments like pulsar timing arrays may someday catch it. You let that debate wash over you like static on a radio. There's something poetic about it. Humanity tuning dials on a cosmic receiver, straining for a signal across eternity, unsure if the music is still playing. The uncertainty itself is oddly soothing. After all, Not knowing means there's still room for discovery. And there's more waiting. New observatories are being built. LISA, a space-based gravitational wave detector, will float in orbit with 3 satellites millions of kilometers apart, linked by lasers, sensitive enough to catch waves too low in frequency for Earth-based detectors. It will be like stretching your ears wider, able to hear deeper, slower songs, the rumbling of supermassive black holes colliding in distant galaxies, the groans of entire stellar systems being torn apart. Imagine that, a cosmic organ pipe resonating across the dark. Even now, pulsars spinning neutron stars that beam radio signals are being used like cosmic metronomes. Scientists measure their ticks with such precision that any disruption hints at passing waves. It's like placing clocks all over the universe and waiting for space-time to make them skip a beat. Already, hints are appearing of a background symphony, perhaps the chorus of supermassive black holes merging across cosmic history. And in this moment, you smile at the thought that you are, right now, inside the orchestra pit. Not outside, not listening from a balcony, but woven into the music itself. Your atoms are vibrating with every wave that passes, your timeline stretching and squeezing in rhythm with distant events. You are not the audience, you are part of the song. Scientists still argue whether consciousness itself could be sensitive, in some way, to such universal rhythms. Could the brain, with its delicate electrical pulses, ever sync subtly with the breathing of space-time? There's no evidence yet, of course, but the possibility tickles your imagination. Maybe the strange sense of awe you feel under the stars isn't only poetic, it could be resonance, your mind humming faintly with the music of the cosmos. And here's where the humor slips in again. If the universe really is humming, then your snoring at night is just you joining the choir. Somewhere, 2 black holes collide, space-time rings like a drum, and here you are, adding a little basso profundo of your own. Don't be embarrassed, you're only keeping time with the cosmos. But beneath the laughter lingers awe. Listening to time's echo teaches humility. You think about how your ancestors once stood on open fields, listening to thunder and imagining gods at war. Now you stand beneath stars, listening to space-time itself, and the awe is no less. It's simply dressed in mathematics and lasers instead of myth. And yet the effect is the same. You feel small, you feel connected, you feel awake inside something immense. The truth is, gravitational waves are not just a new kind of astronomy, they are a new sense altogether. For the first time, humanity has expanded beyond sight, into touch. You are touching the universe across unimaginable distances, feeling its tremors like a hand pressed against the chest of a giant. And when the giant's heart beats, you know it instantly, even from 1 billion light-years away. And so, as you drift deeper into the thought, you realize that listening to time's echo is not about data, graphs, or Nobel Prizes. It is about intimacy. You are not just learning about black holes merging, you are feeling them. You are letting the universe press its story into your very bones. The symphony continues. More waves will come, more ripples will wash through you, and each one is another verse in the song of time, a lullaby written by the stars themselves. You tilt your head back, and for a moment the night sky feels less like an empty canvas of stars and more like a ceiling full of invisible hail. Not the kind of hail that dents your car hood, but ghostly particles, the cosmic rays that slam into Earth every second, each one carrying a message from the farthest corners of the universe. They arrive at nearly the speed of light, so fast that time barely touches them. And you? You're standing right in their stream, like a figure beneath a perpetual shower you can't feel but is always there. It's strange to think that the cosmos is pelting you constantly, as though the universe has been sending postcards for billions of years, but it chose to write them in a secret language of particles. Cosmic rays are not gentle. They are high-energy protons, nuclei, sometimes heavier ions, forged in the furnaces of exploding stars, hurled from black hole jets, or born in collisions between galaxies themselves. They don't ask permission before striking Earth. They simply crash through the atmosphere, smashing into atoms and creating cascades of secondary particles, a shower of invisible fireworks that rains down over everything, including you. There's something quietly humbling about that. You spend so much of your day inside walls, thinking you're protected from the wilds of the universe, but even here, even now, the universe finds its way in. A single square meter of you receives thousands of cosmic ray hits every second. It's almost as if space-time is tapping you on the shoulder, whispering, "Remember where you came from." Scientists first discovered cosmic rays by accident. In the early 1900s, physicists noticed that electroscopes devices for measuring electric charge kept discharging even in sealed containers. The suspicion was that radiation must be seeping in from somewhere. A man named Victor Hess decided to test this by taking a balloon up into the sky. The higher he went, the stronger the radiation became. He realized it wasn't the Earth itself, it was the sky, the universe. For this discovery, Hess won the Nobel Prize. You imagine him floating above the clouds, realizing that space was reaching down, brushing against his instruments, insisting on being noticed. What makes cosmic rays so mysterious is their energy. Some arrive with energies 1,000,000 times greater than anything Earth can produce, even in the mightiest particle accelerators. They are so energetic that scientists have nicknamed the highest energy ones "Oh my God particles," a phrase born not out of scientific rigor, but from sheer disbelief. One such particle carried the same kinetic energy as a fast-pitched baseball, yet it was packed into a single proton smaller than an atom. Imagine holding the weight of a baseball game in the palm of your hand, compressed into a speck of matter invisible to your eye. That's what the universe tosses at you, without warning, across distances of millions or billions of light years. Where do they come from? That's still a debate, an open puzzle carved into the sky. Some scientists argue they are birthed in the violent shocks of supernova remnants, where magnetic fields whip particles to speeds unimaginable. Others believe they come from active galactic nuclei, supermassive black holes spitting jets that stretch farther than galaxies themselves. And then there are the romantics who wonder whether cosmic rays could be whispers from phenomena we haven't yet imagined: dark matter collisions, cosmic strings, or the decay of exotic particles left over from the Big Bang. The truth is, the universe hasn't given up all its secrets yet. The debate continues, lively, unresolved, like an unfinished symphony. You think of Earth's atmosphere as both a shield and a stage. When a cosmic ray strikes, it sets off a cascade of secondary particles called an air shower. Imagine throwing a single marble at a tower of glass, and the fragments scattering in every direction, each fragment colliding with others, multiplying the chaos. These showers can spread across several square kilometers by the time they reach the ground. Detectors like the Pierre Auger Observatory in Argentina cover huge swaths of land with water tanks and sensors, waiting for these fleeting signals. And each time one is caught, it's like intercepting a cosmic telegram, written in particles instead of words. It's funny, in a way, to think of cosmic rays as interstellar gossip. They tell stories of their violent origins, but never clearly. Their paths bend and twist in magnetic fields, their identities hidden, their histories scrambled. By the time they arrive at Earth, they are like rumors carried across oceans, distorted, half true, half lost. Yet even in their distortion, they whisper of explosions, collisions, and ancient engines of creation. Here's the quirky bit. Cosmic rays are part of you, not just striking you now, but shaping your history. Some of the mutations in DNA, those random sparks of change that allowed evolution to stumble forward, may have been triggered by cosmic rays. Without them, life on Earth might have evolved differently, or not at all. The very process that made you human might be written in part by invisible particles from distant stars. You are, in a literal sense, a child of cosmic rays. And here's another curiosity. Cosmic rays even sneak into your electronics. On rare occasions, a cosmic ray strike can flip a bit in a computer's memory, changing a 0 to a 1, or vice versa. It's called a single event upset. In 2003, a cosmic ray strike is believed to have altered a voting machine in Belgium, giving one candidate 4,096 extra votes. The error was caught, but the lesson is clear. The universe occasionally meddles in your affairs, not with intent, but with random, particle-born mischief. Imagine explaining that to a confused election committee. The stars made me win. As you settle deeper into thought, you realize how strange it is that cosmic rays turn Earth into a kind of cosmic crime scene. You can't trace them back directly, but you can study the clues they leave behind. Like detectives, scientists piece together the direction, the energy, the secondary showers. It's slow, patient work, listening to a universe that speaks in cryptic Morse code. And all the while, the waves and rays keep coming. Gravitational waves stretch your timeline. Cosmic rays puncture your cells. Both are reminders that you're not separate from the cosmos, but stitched into its fabric. You are not just looking at the universe, you are immersed in it, bathed in its particles, ripples and whispers. You picture yourself standing on the edge of a cosmic observatory, arms open, as though you could catch these invisible messengers in your hands. Of course, if you actually tried, you wouldn't notice a thing. Cosmic rays don't glow, they don't make noise, and most of them pass through you without leaving a trace. Yet some, the rare powerful ones, collide with your atoms, tiny cosmic fender benders that alter reality in ways both subtle and profound. One of the strangest truths is that you're not just being struck by today's universe, you're being struck by its history. Some cosmic rays were born billions of years ago, in galaxies so distant that the light from their parent explosions hasn't even reached Earth yet. And yet, the particles themselves, bent and redirected, manage to arrive here. You, in this very moment, are interacting with an event you can never see, a firework from a galaxy forever beyond your eyes. That's the peculiar nature of cosmic rays, they let you touch the unreachable. Consider the way scientists detect them. You'd think you could just build a telescope and point it at the sky, but cosmic rays refuse to cooperate. They arrive as individual particles, not beams of light. So instead, researchers build vast arrays across deserts, covering miles with detectors that listen for the rain of secondary particles. The Pierre Auger Observatory, sprawling across the Argentine pampas, is one of these cosmic ears. Every time a high-energy particle slams into the atmosphere, the observatory captures the echoes. It's like listening for drops of rain, except the storm comes from galaxies away. But even the Earth itself helps out. When cosmic rays strike the atmosphere, they produce showers of muons, short-lived cousins of the electron. These muons have enough energy to penetrate rock and soil, and in recent years scientists have used them as a kind of natural X-ray. By measuring how muons scatter, researchers can see inside volcanoes, map the hidden chambers of pyramids, even peer into the cores of nuclear reactors. Imagine that, particles born in exploding stars, travelling across the galaxy, helping humans peek inside an ancient pyramid built by hands long dead. If that doesn't make you marvel at the interconnectedness of things, nothing will. And then, there's the question of origins, that unresolved debate that keeps scientists awake. Are cosmic rays mostly from supernovae, as the traditional view holds? Or do the most energetic ones demand something more exotic, like active galactic nuclei or gamma-ray bursts? Some even suggest top-down origins, relics of the Big Bang itself, decaying particles from an early universe far hotter and stranger than anything you can currently imagine. Each possibility is tantalizing, because it means that cosmic rays aren't just curiosities, they're clues to the deepest processes in the cosmos, fragments of stories written long before Earth cooled. Here's a light-hearted twist. Cosmic rays have a way of photobombing astronomy. Astronomical images, especially from sensitive detectors like the Hubble Space Telescope, often show streaks or flashes caused by stray cosmic rays striking the sensors. A researcher could spend hours perfecting an image of a distant galaxy, only to find an annoying cosmic squiggle scribbled across it, courtesy of a random particle travelling halfway across the universe. You could almost imagine the cosmos chuckling, leaving doodles on humanity's homework. But the joke hides a deeper truth. These particles don't just interfere with our instruments, they remind us that we are participants in the universe, not mere spectators. Every piece of technology, every memory chip, every human cell is part of the cosmic crossfire. It's not hostile, it's simply the way of things. The universe is not a quiet museum where objects sit on display behind velvet ropes. It is a restless arena, particles flying, energies colliding, whispers being exchanged in silence. You wonder how much of yourself is written in this language of cosmic rays. Each one is small, but together, across billions of years, they might have nudged evolution, shaped storms, altered chemistry in ways impossible to fully track. Some scientists speculate that cosmic rays could even influence cloud formation on Earth, subtly affecting weather and climate. Imagine that a storm in your town might carry the fingerprint of a star that died a billion years ago. And then your mind drifts to the scale of it all. Cosmic rays are not confined to Earth, they pervade the entire galaxy, filling it like a thin, invisible fog. They flow between stars, around planets, through magnetic fields. They are both particles and storytellers, carrying tales of destruction and creation. Each one is a piece of cosmic archaeology, older than civilizations, older than Earth's mountains, older even than the sun itself. You think back to the "oh my God" particle, that almost absurdly energetic visitor from space. It reminds you how small humanity's technology is compared to the universe's accelerators. Your largest particle colliders, such as the Large Hadron Collider in Geneva, can accelerate protons to incredible speeds, but they are toys compared to the natural accelerators out there. Somewhere, hidden in the darkness, magnetic fields 1,000,000 times stronger than anything humans can build are flinging particles with unimaginable force. It's humbling. You spend billions of dollars to coax particles into collisions, while the universe casually tosses them out across billions of light years. And yet, it's comforting too, because every time you detect a cosmic ray, you are catching a gift from that vast machinery. You are, in some sense, in conversation with the universe. Not a conversation of words, but of particles, an exchange written in the very fabric of reality. So tonight, as you lie back and listen, you might imagine cosmic rays differently. Not as invisible bullets, but as letters sent across time. Some carry energy beyond your imagination. Some tell of explosions so far away they stretch the meaning of distance. Some may even hint at truths still hidden, new physics, unknown particles, the faint shadow of dark matter. And all of them arrive here, at your doorstep, tapping gently on the roof of your atmosphere, waiting to be noticed. The secret, of course, is that you are not just a listener, you are part of the story. Every time a cosmic ray strikes your body, every time it sneaks into your cells or flips a bit in your laptop, it folds you deeper into the narrative of the universe. You are both the observer and the canvas. You are both the detective and the evidence. You are, whether you like it or not, one of the secrets that cosmic rays reveal. You lie there, imagining the universe not just as it is now, but as it may one day become. Time, after all, has always felt like a faithful companion, steady, dependable, ticking forward whether you like it or not. But what if it isn't eternal? What if there comes a day when time itself runs out, like the last page of a book? It sounds absurd, almost poetic, but physicists take the possibility seriously. The end of time is not just a philosophical musing. It is a scenario drawn from the mathematics of cosmology, the physics of entropy, and the strange silence that lies in the far future of the universe. You start close to home. Right now, the universe is still young by cosmic standards, just shy of 14 billion years old. Stars are shining, galaxies are colliding, life on Earth continues its restless unfolding. If you had a cosmic calendar, you'd see that you are barely past dawn. Yet already, the seeds of the end are present. Stars, the engines of time as you know it, are finite. They burn fuel, exhaust themselves and collapse. Imagine one by one, suns extinguishing like street lamps along an infinite road, until only darkness remains. That alone could signal the dimming of time as you experience it. Without stars, days and nights lose their rhythm, and what remains is a silent stretch of eternity. But the end of time isn't just about starlight fading, it's about the very structure of reality breaking down. Consider entropy, that quiet tyrant. Every process in the universe adds a little more disorder, like clutter piling up in a room. You can tidy for a while, but in the long run, the mess wins. In cosmic terms, entropy grows until nothing meaningful remains to change. That moment, sometimes called heat death, is not fiery at all. It is stillness. A universe where everything is so evenly spread out that no clocks can tick, because ticking requires difference. Hot to cold, high to low, ordered to disordered. Without difference, time has no arrow. It doesn't just stop, it becomes meaningless. You might as well be asking what time it is inside a puddle of lukewarm soup. And yet, not all scientists agree this is the only fate. Some imagine the opposite, a big crunch, where the universe's expansion reverses. Instead of galaxies flying apart, they rush inward, drawn by their mutual gravity, until everything collapses into a final cosmic implosion. In such a scenario, Time ends in a blaze of unimaginable violence, the opposite of heat death's cold whisper. But here's the twist. The laws of physics don't forbid time from restarting. Out of the ashes of a crunch could come another bang. If that's true, then time is less like a straight line and more like a heartbeat, expanding and contracting forever. Of course, there are stranger possibilities. One is the Big Rip, in which dark energy, this mysterious pressure accelerating the universe's expansion, grows stronger over time. Galaxies drift apart, then stars, then planets, and finally even atoms are torn asunder. Picture the universe, unraveling thread by thread, until even space-time itself splits. If that happens, time doesn't end neatly, it shreds. Your watch wouldn't just stop, it would disintegrate along with your arm, the earth, and eventually the fabric that defines before and after. Cheerful bedtime thoughts, right? Scientists still argue whether any of these fates is more likely. Observations suggest dark energy is real and persistent, pointing toward eternal expansion and possible heat death. But the precise nature of dark energy is unknown, and if it changes its behavior in the future, the story could be entirely different. That uncertainty keeps the discussion alive. In truth, you live in a universe whose ending is still a mystery novel with half the pages missing. Let's take a step sideways, though. Suppose time doesn't end in a spectacular collapse or freeze. Maybe it fades into something unrecognizable, like a melody stretched until it becomes silence. Quantum physics hints at this possibility. At the smallest scales, particles fluctuate, blink in and out of existence. Some physicists wonder if time itself is not fundamental but emergent like temperature, which only makes sense when you have trillions of molecules jostling. If that's true, then at some ultimate horizon, when the universe is too sparse, time itself may dissolve, like frost under sunlight. You wouldn't see a cataclysm. You'd just never notice time passing again. And here comes a quirky tidbit. Philosophers once debated whether time is real or merely a measure of change. The ancient Greeks had no clocks, but they had sunsets and harvests, seasons and aging. What if time is nothing more than your brain's way of stringing events together? If so, then the end of time might not be physical at all, it could be cognitive. If there's no one left to perceive change, does time still exist? That's not just an armchair thought experiment. Some cosmologists genuinely ask whether a universe without observers has meaning. After all, if no one hears the last tick, did the clock really stop? And because your imagination is restless, you turn to the multiverse. In some theories, your universe is only one bubble among countless others, each with its own laws. If time ends here, perhaps it continues elsewhere, or perhaps new universes constantly bud off from black holes, carrying fragments of their parents' history. You might be living in a cosmic forest where endings are illusions, because every fall of one leaf coincides with the sprouting of another. In that view, time is inexhaustible, but never in the same place twice. Now, for a more playful moment, imagine you could mail a postcard to the end of time. What would you write? Wish you were here? It's quiet? Too quiet? Humor helps, because the reality is almost too immense to face. If time ends in heat death, no one will be around to send or receive postcards. If it ends in a crunch, there won't even be paper left. But the act of imagining it is part of what makes you human. To consider the end of time is to stretch your mind beyond survival and into wonder. Still, the question lingers, why should this matter to you tonight as you drift off in your bed? After all, the end of time, whether trillions or quadrillions of years away, won't affect your morning alarm. But it does something subtler. It gives you perspective. When you realize even time may not be eternal, your small worries seem lighter. That late email, that missed appointment, they are pebbles compared to the mountain of eternity. And perhaps there's comfort in knowing that your life, your thoughts, your laughter, are sparks against a backdrop so vast it may one day dissolve entirely. So you turn over, letting the thoughts settle. The end of time might be a silence so deep it erases all questions, or it might be a rebirth, another dawn hidden inside a cosmic night. Either way, it reminds you of something essential. Your moments are precious, precisely because they are temporary, and that truth, paradoxically, is timeless. You find yourself picturing the farthest imaginable tomorrow, a day so remote that stars are nothing but whispers in the background, and galaxies drift apart like forgotten islands. It's a day when calendars would be meaningless, not because no one is left to mark them, but because the universe itself has lost the rhythm that makes time tick. Time is only useful when change exists, when something happens, but in the great silence of the far future, change may cease, and in that stillness the very word time dissolves. The story of time's ending begins with the fuel of the stars. Already, every star you see overhead is locked into its own countdown. The sun has about 5 billion years left before it expands into a red giant and fades into a quiet ember. But the largest stars live far shorter lives, some exploding after only a few million years. Imagine every streetlight in a great city slowly going out. At first the pattern seems random, but given enough ages, the whole grid goes dark. That is the fate awaiting the Milky Way, the Andromeda galaxy, and every other cosmic neighborhood, a long twilight spreading across the universe. What comes next is stranger. After stars die, what remains are husks, white dwarfs cooling into black dwarfs, neutron stars spinning in silence, black holes lurking like cosmic drains. At first, these remnants seem eternal, but even they cannot last. Black holes slowly evaporate through Hawking radiation, leaking energy across unimaginable spans of time. A black hole with the mass of your sun would take about 10 to the power of 67 years to vanish. Larger ones, those found at galactic centers, would last even longer, up to 10 to the power of 100 years. That number is absurd, beyond counting, but still finite. Eventually, all the giants will exhale their last photons into the void. At that point, what does time mean? A universe of faint particles drifting in infinite night has nothing left to mark the difference between then and now. And here, scientists reach for phrases that border on poetry: the heat death, the eternal freeze, a cosmos where nothing new can ever occur. If you were somehow alive to witness it, your sense of time might feel like being locked in a room where the clock has stopped, but your thoughts continue until even they fade. But others refuse this vision of silence. They imagine instead that gravity may reclaim the stage. If dark energy is not constant but changes with time, then expansion could slow and reverse. Galaxies would not drift apart but begin collapsing inward, first gently, then violently, until the cosmos ends in a fireball. To you, it would look as though time were speeding up, events crowding closer together as all matter rushes toward a single point. The end would come not as a fade to black, but as an overwhelming crescendo. This big crunch has a certain symmetry, an echo of the Big Bang that started it all. And here lies one of the great debates. Is the universe doomed to silence or rebirth? Some cosmologists argue that a crunch might ignite a new expansion, a fresh Big Bang. In that case, time does not end, it cycles. Perhaps you live in just one beat of an infinite cosmic heart, each expansion followed by contraction, each universe born from the death of the last. If true, then everything you know, your life, your planet, your history, may return in some distant cycle, playing out again in an unending loop. Then there is the strangest fate of all, the Big Rip. In this model, dark energy grows stronger with time. Expansion does not just continue, it accelerates without limit. Galaxies first, then solar systems, then planets are pulled apart. In the final instance, atoms themselves are torn open, the very structure of matter undone. You could call it the apocalypse of physics. And because space-time itself unravels, time does not just stop, it ceases to exist. If the heat death is like running out of story, the Big Rip is like tearing the book in half. Physicists admit they don't know which fate awaits. Observations suggest expansion is accelerating, pointing toward heat death or Big Rip, but the exact behavior of dark energy remains elusive. It's a reminder that even the cosmos holds mysteries too large for your brief species to solve. And maybe that is fitting. After all, if you could know the end of time, wouldn't that make the story less interesting? You pull the blanket tighter, smiling at the absurdity. Here you are, worrying about tomorrow's errands, while somewhere in the equations of physics lies the ultimate end of tomorrow itself. The humor is in the mismatch. You worry about minutes, but the universe worries about eons, and yet, in its way, this vast question comforts you. The end of time, whether freeze, crunch or rip, is so far beyond your reach that it frees you from responsibility. You are simply a guest, watching one act in a drama that stretches beyond imagination. Scientists still argue whether time can even be said to end. Maybe time is not a thing but a perception. Maybe the universe continues, but so quietly and slowly that it looks timeless. Or maybe new physics, yet undiscovered, will open possibilities no one today can dream of. You could laugh and say, the end of time might itself take forever. And with that thought, you close your eyes, imagining that final horizon. Will it be silence, fire, or rebirth? No one knows. But what you do know is this: each moment you have now, every tick of your clock, is infinitely precious. Because no matter how time ends, this instant is yours. You find yourself picturing the farthest imaginable tomorrow, a day so remote that stars are nothing but whispers in the background and galaxies drift apart like forgotten islands. It's a day when calendars would be meaningless, not because no one is left to mark them, but because the universe itself has lost the rhythm that makes time tick. Time is only useful when change exists, when something happens. But in the great silence of the far future, change may cease, and in that stillness, the very word time dissolves. The story of time's ending begins with the fuel of the stars. Already every star you see overhead is locked into its own countdown. The sun has about 5 billion years left before it expands into a red giant and fades into a quiet ember. But the largest stars live far shorter lives, some exploding after only a few million years. Imagine every streetlight in a great city slowly going out. At first the pattern seems random, but given enough ages, the whole grid goes dark. That is the fate awaiting the Milky Way, the Andromeda galaxy, and every other cosmic neighborhood, a long twilight spreading across the universe. What comes next is stranger. After stars die, what remains are husks. White dwarfs cooling into black dwarfs, neutron stars spinning in silence, black holes lurking like cosmic drains. At first these remnants seem eternal, but even they cannot last. Black holes slowly evaporate through Hawking radiation, leaking energy across unimaginable spans of time. A black hole with the mass of your sun would take about 10 to the power of 67 years to vanish. Larger ones, those found at galactic centers, would last even longer, up to 10 to the power of 100 years. That number is absurd, beyond counting, but still finite. Eventually, all the giants will exhale their last photons into the void. At that point, what does time mean? A universe of faint particles drifting in infinite night has nothing left to mark the difference between then and now. And here, scientists reach for phrases that border on poetry. The heat death, the eternal freeze, a cosmos where nothing new can ever occur. If you were somehow alive to witness it, your sense of time might feel like being locked in a room where the clock has stopped, but your thoughts continue until even they fade. But others refuse this vision of silence. They imagine instead that gravity may reclaim the stage. If dark energy is not constant but changes with time, then expansion could slow and reverse. Galaxies would not drift apart but begin collapsing inward, first gently, then violently, until the cosmos ends in a fireball. To you it would look as though time were speeding up, events crowding closer together, as all matter rushes toward a single point. The end would come not as a fade to black but as an overwhelming crescendo. This big crunch has a certain symmetry, an echo of the Big Bang that started it all. And here lies one of the great debates. Is the universe doomed to silence or rebirth? Some cosmologists argue that a crunch might ignite a new expansion, a fresh Big Bang. In that case, time does not end, it cycles. Perhaps you live in just one beat of an infinite cosmic heart, each expansion followed by contraction, each universe born from the death of the last. If true, then everything you know, your life, your planet, your history, may return in some distant cycle, playing out again in an unending loop. Then there is the strangest fate of all, the Big Rip. In this model, dark energy grows stronger with time. Expansion does not just continue, it accelerates without limit. Galaxies first, then solar systems, then planets are pulled apart. In the final instance, atoms themselves are torn open, the very structure of matter undone. You could call it the apocalypse of physics. And because space-time itself unravels, time does not just stop, it ceases to exist. If the heat death is like running out of story, the Big Rip is like tearing the book in half. Physicists admit they don't know which fate awaits. Observations suggest expansion is accelerating, pointing toward heat death or Big Rip, but the exact behavior of dark energy remains elusive. It's a reminder that even the cosmos holds mysteries too large for your brief species to solve, and maybe that is fitting. After all, if you could know the end of time, wouldn't that make the story less interesting? You pull the blanket tighter, smiling at the absurdity. Here you are, worrying about tomorrow's errands, while somewhere in the equations of physics lies the ultimate end of tomorrow itself. The humor is in the mismatch. You worry about minutes, but the universe worries about eons, and yet, in its way, this vast question comforts you. The end of time, whether freeze, crunch, or rip, is so far beyond your reach that it frees you from responsibility. You are simply a guest, watching one act in a drama that stretches beyond imagination. Scientists still argue whether time can even be said to end. Maybe time is not a thing but a perception. Maybe the universe continues, but so quietly and slowly that it looks timeless. Or maybe new physics, yet undiscovered, will open possibilities no one today can dream of. You could laugh and say, the end of time might itself take forever. And with that thought, you close your eyes, imagining that final horizon. Will it be silence, fire, or rebirth? No one knows. But what you do know is this: each moment you have now, every tick of your clock, is infinitely precious. Because no matter how time ends, this instant is yours. You linger on that vision of a council, beings who live in different tempos of time, trying to converse across gulfs of perception. And it reminds you that even here on Earth, you already live in a world where time feels subjective. For a hummingbird, a single second is packed with wing beats, colours, and movements too quick for your eye to follow. For a tortoise, the same second passes like a soft breeze, barely anything at all. So why not imagine that aliens or AI would stretch this gap until it spans centuries? Imagine standing on the bridge of a starship beside an AI co-pilot. You blink, and it has already run through millions of strategies for survival, optimization, navigation. To you, a minute has passed. To the AI, entire civilizations of thought have risen and fallen inside its circuits. It leans back if machines could lean, and says, I've considered every possible future, and here's the one worth chasing. You nod, pretending you followed its logic, but you didn't. You never could. And that's okay, because maybe part of humanity's role is not to keep up with time, but to marvel at the shapes it takes. Now zoom back to aliens again. If life has sprouted in countless corners of the cosmos, time dilation might shape who survives long enough to be noticed. Civilizations born in gentle gravity wells may flicker fast, like candles burning quickly in calm air. Others, forged in the deep wells of massive stars or black holes, may endure for what seems like eons from your perspective. Perhaps those civilizations would look at you the way you look at fireflies' brief sparks in the long night of the universe. You don't mean to be short-lived, but compared to them, you are. And perhaps compared to AI, they are. Here's where the quirky bit comes in. What if communication itself becomes a form of time art? Maybe future humans and alien minds will create tempo translators, machines that stretch or compress conversations, letting you chat with a being who thinks 1,000 times faster or slower than you. In practice, it would feel like a radio tuned, not to a frequency but to a speed. You'd speak, your words would be slowed or accelerated, and the alien or AI would hear you as if you shared the same rhythm. To you it's a conversation, to them it's a miracle of patience. Scientists still argue whether such translation is realistic or just science fiction, but the metaphor is powerful, because it suggests that no matter how differently time flows, the longing for connection remains universal. You might not dance to the same tempo, but you still hear the same song. Now, picture a universe seeded with probes, tiny machines carrying not weapons but clocks. Each probe drifts into interstellar space, some near black holes, some racing at relativistic speeds, others resting in calm regions between galaxies. They all measure time differently, like drummers in a cosmic orchestra, and when they beam their data back, if they ever can, you'd receive a symphony of tempos, a collage of realities. Humanity could listen not just to what the universe is, but to how it feels to live in different slices of it. That might be the truest form of exploration, not travelling to places, but travelling to times. This thought slides into philosophy. What does it mean if your species, your machines, or your alien neighbors all inhabit different timelines? Maybe it means that the idea of a single present moment was never real in the first place. You live in a quilt of nows, stitched loosely together, and time dilation only pulls the threads further apart. But maybe that's not a flaw, it's the design, because difference creates perspective, and perspective creates meaning. A chuckle slips out of you. You realize the ultimate cosmic joke might be this. By the time humanity finally meets aliens or births true AI, one side might already see the other as ancient history. You shake your head. What a way to miss a party. But then again, maybe that's how the universe keeps things interesting, by making sure the punchline always lands in a different century than the setup. Still, you return to the practical. Time dilation has already shaped how you use technology on Earth. GPS satellites, circling high above, tick slightly faster than clocks on the ground, and engineers must correct for it. Without those corrections, your map app would drift miles off course in just a day. Now extend that logic to future starships, alien empires, or machine minds. They'll need to correct not just for meters, but for millennia. Navigation will be less about distance and more about tempo. How fast is your clock compared to mine? And this leads to the heart of it. Alien clocks and AI futures are not just curiosities, they're the scaffolding of tomorrow's civilizations. If consciousness endures, whether in flesh, silicon, or something stranger, it will have to wrestle with the truth that time is not uniform. It bends, it flows, it splits. And yet, against all odds, minds will still try to meet across it. That desire to connect may be the one constant, the rhythm that unites every drummer in the cosmic orchestra. You breathe, slowly, letting the idea settle, that the future of time is not a uniform ticking but a chorus of tempos. Some slow, some fast, some incomprehensible, but all part of the same vast song. You linger on that vision of a council, beings who live in different tempos of time trying to converse across gulfs of perception. And it reminds you that even here on Earth, you already live in a world where time feels subjective. For a hummingbird, a single second is packed with wing beats, colours, and movements too quick for your eye to follow. For a tortoise, the same second passes like a soft breeze, barely anything at all. So why not imagine that aliens or AI would stretch this gap until it spans centuries? Imagine standing on the bridge of a starship, beside an AI co-pilot. You blink, and it has already run through millions of strategies for survival, optimization, navigation. To you, a minute has passed. To the AI, entire civilizations of thought have risen and fallen inside its circuits. It leans back if machines could lean and says, "I've considered every possible future, and here's the one worth chasing." You nod, pretending you followed its logic, but you didn't. You never could. And that's okay, because maybe part of humanity's role is not to keep up with time, but to marvel at the shapes it takes. Now zoom back to aliens again. If life has sprouted in countless corners of the cosmos, time dilation might shape who survives long enough to be noticed. Civilizations born in gentle gravity wells may flicker fast, like candles burning quickly in calm air. Others, forged in the deep wells of massive stars or black holes, may endure for what seems like eons from your perspective. Perhaps those civilizations would look at you the way you look at fireflies, brief sparks in the long night of the universe. You don't mean to be short-lived, but compared to them, you are. And perhaps compared to AI, they are. Here's where the quirky bit comes in. What if communication itself becomes a form of time art? Maybe future humans and alien minds will create tempo translators machines that stretch or compress conversations, letting you chat with a being who thinks 1,000 times faster or slower than you. In practice, it would feel like a radio tuned not to a frequency but to a speed. You'd speak, your words would be slowed or accelerated, and the alien or AI would hear you as if you shared the same rhythm. To you, it's a conversation. To them, it's a miracle of patience. Scientists still argue whether such translation is realistic or just science fiction, but the metaphor is powerful, because it suggests that no matter how differently time flows, the longing for connection remains universal. You might not dance to the same tempo, but you still hear the same song. Now picture a universe seeded with probes, tiny machines carrying not weapons but clocks. Each probe drifts into interstellar space, some near black holes, some racing at relativistic speeds, others resting in calm regions between galaxies. They all measure time differently, like drummers in a cosmic orchestra, and when they beam their data back, if they ever can, you'd receive a symphony of tempos, a collage of realities. Humanity could listen not just to what the universe is, but to how it feels to live in different slices of it. That might be the truest form of exploration, not travelling to places, but travelling to times. This thought slides into philosophy. What does it mean if your species, your machines, or your alien neighbours all inhabit different timelines? Maybe it means that the idea of a single present moment was never real in the first place. You live in a quilt of nows, stitched loosely together, and time dilation only pulls the threads further apart. But maybe that's not a flaw, it's the design, because difference creates perspective, and perspective creates meaning. A chuckle slips out of you. You realize the ultimate cosmic joke might be this. By the time humanity finally meets aliens, or births true AI, one side might already see the other as ancient history. You shake your head. What a way to miss a party. But then again, maybe that's how the universe keeps things interesting, by making sure the punchline always lands in a different century than the setup. Still, you return to the practical. Time dilation has already shaped how you use technology on Earth. GPS satellites, circling high above, tick slightly faster than clocks on the ground, and engineers must correct for it. Without those corrections, your map app would drift miles off course in just a day. Now extend that logic to future starships, alien empires, or machine minds. They'll need to correct not just for meters, but for millennia. Navigation will be less about distance and more about tempo. How fast is your clock compared to mine? And this leads to the heart of it. Alien clocks and AI futures are not just curiosities, they're the scaffolding of tomorrow's civilizations. If consciousness endures, whether in flesh, silicon, or something stranger, it will have to wrestle with the truth that time is not uniform. It bends, it flows, it splits. And yet, against all odds, minds will still try to meet across it. That desire to connect may be the one constant, the rhythm that unites every drummer in the cosmic orchestra. You breathe, slowly, letting the idea settle, that the future of time is not a uniform ticking but a chorus of tempos, some slow, some fast, some incomprehensible, but all part of the same vast song. You sit with the idea a little longer, letting it ripple through your imagination. To be a thread in space-time means you're never really separate from anything else. Every movement you've ever made, every word you've spoken, every laugh, sigh, or stumble, all of it curls into this continuous line that binds you into the great cosmic weave. And it's not just you. Every person you've ever met, your parents, a stranger you brushed shoulders with in the street, and the mail carrier, a friend from childhood, they are threads too, stretching alongside yours. Sometimes you run parallel for years, sometimes you cross for just a fleeting instant, like a spark of light that flickers and then disappears, but the crossing itself is stitched forever. That moment cannot be undone. Here's the beautiful thing. From your perspective, you may forget it. You may not remember the time you accidentally held open a door for someone at the grocery store in 2009. But in space-time, it's there, fixed, an eternal marker of kindness or chance, and that person's thread still holds the impression of yours. It's humbling to think that so much of what you are exists not in your memory but in the universe itself. You could argue that your memories are just one perspective, but the fabric of space-time contains the truth of your entire life, all the details, not just the ones you can recall. In a sense, you are more permanent in the universe's memory than in your own. And that permanence raises strange questions. If your whole life already exists as a thread, does that mean your death is already out there too, waiting on the far end? It sounds grim, but it doesn't have to be. Think of a book. The final chapter is already written even as you're still reading page 32. You wouldn't close the book in despair because the ending exists. You'd keep reading, savouring each page, knowing that the story is richer because it has shape. Physicists who lean toward this block universe idea often find themselves in philosophical territory. Is time an illusion? Are we simply perceiving our thread from one angle, like a flashlight beam sliding along a frozen sculpture? Scientists still argue whether this interpretation is the truth or just a convenient way to describe equations. Some believe in a flowing present, where time is born in each moment and the future does not yet exist. Others believe that past, present, and future are equally real, and your sense of flow is just consciousness moving along your thread. You might smile here, because either way, you still feel the flow. You still wake up, eat breakfast, get sleepy at night. You live in the illusion of time's arrow, whether it's truly an illusion or not, and maybe that's the point. Your experience is what matters to you, regardless of the deeper architecture. But let's play with the metaphor. Imagine zooming out to see all threads at once. Humanity becomes a vast glowing braid, knotted with intersections diverging and converging in a million ways. Now zoom out farther, and you see not just people but animals, plants, every living thing all woven into the braid. The cat curling up on a windowsill, the whale diving deep into the Pacific, the bird building a nest in spring, all threads stitched alongside yours. Then beyond life itself, the thread of a mountain slowly eroding, of a star collapsing, of a galaxy spiraling. Matter and energy themselves trace paths through space-time. The weave becomes dense, rich, impossible to untangle. And there, in the middle of it, is you. Small, yes, but not insignificant. Without your thread, the pattern would be different. Even the tiniest strand changes the whole. This is where things get deliciously strange. If you are a thread in space-time, then in some sense, you are immortal. Not in the way you may want, not with endless birthdays or forever youth, but in the sense that every moment of your existence is preserved in the fabric. The you who first learned to ride a bike is still there. The you who laughed too hard at a silly joke is still there. The you who sat quietly one night and felt infinite loneliness is still there too. They haven't gone anywhere. They are stitched forever into the geometry of reality. And if that doesn't make you feel a little magical, here's a quirky tidbit. Physicists sometimes describe spacetime diagrams as world lines. Each object has one. The Earth has one. The Moon has one. Every particle has one. And yours is as real as the Moon's or Earth's to the universe. Your world line matters as much as Jupiter's orbit. The cosmos is impartial that way. So tonight, as you sit listening, you might let yourself drift into this thought. You are more than fleeting. You are a pattern, an entire shape. And every choice you've made is part of the line that cannot be erased. Even the mistakes, the ones you wish you could cut out, they're part of the shape too, giving your thread its unique bend. Now imagine what happens when threads end, or at least appear to. Death feels final from inside the flow, but in the fabric, your thread is complete, not erased. It exists in its entirety. Some thinkers find in this a strange kind of comfort, that death is not vanishing but the full curve of your existence, visible forever in space-time. Others resist. Scientists still argue whether time's geometry implies permanence, or whether we simply impose that interpretation because our brains crave meaning. But perhaps the debate doesn't diminish the wonder. Whether eternal or fleeting, your thread is yours, and it is already extraordinary that you exist at all. So you take another breath, feeling the weight of your thread in space-time, not as a burden but as an anchor. You belong. You are written. You are stitched into the very fabric of reality. You've travelled so far tonight across galaxies, through black holes, past paradoxes, into the thick fabric of space-time itself. And here, at the edge of our journey, the question lingers like a soft echo. What does it all mean for you? For all of us? The universe is waiting not passively, not coldly, but as though it has been unfolding into this very moment, right here, where you sit listening, wrapped in your own quiet. Think of the phrase again. You are not in time, you are time itself. It sounds like poetry at first, a comforting metaphor whispered to soften the existential chill of physics. But the more you let it steep, the more it feels like a revelation. You aren't just carried along by the river of time, you're a tributary of it, flowing, branching, colliding with other streams. When you laugh, when you grieve, when you dream, those aren't just things happening inside time, they are time manifesting as you. Mainstream physics gives you the scaffolding for this realization. General relativity treats space-time as a single entity, not a backdrop where things happen, but a participant in the drama of existence. Matter tells space-time how to curve, and space-time tells matter how to move. That includes you. Your atoms dance along curves in space-time shaped by Earth's gravity. Your cells tick along with biological clocks tuned by the sunday. In that sense, your very being is inseparable from the fabric. But let's add the quirky layer, because the cosmos loves quirks. Scientists once discovered that the neurons in your brain, those fragile little electrical cells that generate thought fire in rhythms that echo cosmic cycles. Not on the same scale, of course, but the harmony is uncanny. Some researchers even suggest consciousness might be tied to oscillations that resemble waves in space-time. It's as though the universe whispers its rhythm through your mind, reminding you, you are not separate from me. Now comes the open debate, the place where science blushes into philosophy. Scientists still argue whether time is fundamental or emergent. Is time built into the foundation of reality, the bedrock beneath physics? Or is it something that appears only when enough matter and energy interact, like the illusion of a rainbow appearing only under the right conditions? If time is emergent, then so are you not a fixed entity but a pattern in motion. If time is fundamental, then you are as eternal as the laws themselves, an inseparable feature of the cosmos. Pause for a breath. Either way, the conclusion is radical. You are not a passenger. You are part of the vehicle itself. You can imagine yourself standing at the threshold of a great cosmic library, shelves stretching so far you can't even see their end. Each shelf is stacked with volumes that aren't written in words but in moments. Your first breath, the first time you tasted something sweet, the laughter you shared in the dark, the heartbreak that bent your chest but also taught you tenderness. Every page is time, every chapter a life. And here's the strange thing, the library isn't outside of you. It is you. Your existence is a corridor through which time itself chooses to wander. This is why the phrase, "the universe is waiting," carries such weight. It isn't that the cosmos has a calendar or a plan written in starlight. It's that your awareness is the very place where the universe pauses to reflect. Every second you live is the universe folding in on itself, asking, "What am I?" And you, unknowingly, answer simply by being here, thinking, breathing, listening. Science frames this truth in its own precise language. Entropy, the measure of disorder, keeps the arrow of time moving forward. Without it, the universe would be trapped in a frozen stillness, unable to change, unable to grow. You, with your shifting thoughts and aging cells, are a tiny node in entropy's vast symphony. You might sigh at the inevitability of wrinkles or the fading of memories, but physics would say, without this forward march, there could be no music at all. And then there's the playful possibility of many worlds. Some interpretations of quantum mechanics suggest that every choice, every twitch of an electron, branches into countless alternate realities. Somewhere, in a different universe, another version of you paused this video already, another forgot to hit play, another is listening right now while floating in a spacecraft far above the Earth. Scientists still argue whether these worlds are real or just mathematical phantoms, but the idea itself bends your mind toward infinity. If they are real, then time is not just something you move through, it's a branching forest, and you are one path of it, one melody of possibility. Think also about the cosmic horizon, the distance beyond which light will never reach you, because the universe's expansion is carrying galaxies away faster than even light can close the gap. Beyond that edge lies a forever unknowable sea, and yet, by simply imagining it, you stretch your consciousness beyond the visible. Your mind becomes larger than the observable universe, because you can think past what your eyes can ever see. So, yes, you are not in time. You are time itself, woven from stardust and memory, flowing forward as both witness and participant. Every breath you take is time breathing through you. Every choice you make is the universe selecting one of its infinite pages, and every dream you have is time whispering back to itself, reminding you of the mystery it always carries. Now, let the pace soften. The grand sweep of galaxies shrinks down again, until you are back where you started, in your own room, at your own hour of night. The stars are still burning far away, but here, the only light might be a lamp on the bedside or the glow of your screen. Feel how the vastness of everything you've heard tonight gently settles into the quiet of this single moment. It's easy to feel small when you think of light years and superclusters, when you realize the observable universe holds 2 trillion galaxies and maybe far more. But small isn't the same as insignificant. In fact, there's something miraculous about being tiny yet aware. The atoms in your body were forged in ancient stars, billions of years before your first heartbeat. You are literally built from the memory of the universe. Every second that passes through you is cosmic history continuing its story. Let yourself relax into that thought. You don't have to hold the entire universe in your hands. It already holds you. The floor beneath you, the air you breathe, the ticking of your heart, they are all part of the great weaving. So, close your eyes if you'd like. Imagine yourself not just drifting through time, but being the current itself. You are the gentle tide moving forward, the echo of galaxies collapsing and stars igniting, the quiet presence of life unfolding in one small corner of infinity. There is no rush. Time doesn't demand you to hurry. It simply asks you to flow. May this thought ease the weight of the day from your shoulders. May it remind you that even in the vast silence of the cosmos, you are heard, you are felt, you are time itself continuing its story. Rest easy now. The universe can wait.